aim of this session?
Just wait for some time. I will let you know. Is the screen is visible to all?
Yes, sir.
Oh, yes, okay. Sir. Let others then join. Then I'll start. I'll let you know what we will discuss in this session and what will be our major topic. Okay.
Hello.
Just wait for some time. I'm fixing my network. I think it's fine now. I'm audible now.
Yes, sir.
Yes, sir.
Yes, sir. The screen is visible to all.
Yes,
Yes,
sir.
sir.
Okay.
So,
Okay. 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 So just wait for 5 minutes. So let's other than join. Then we'll start the session. Okay.
Sure, sir.
Okay. So the new batch is here, right?
Yes, sir.
Is there anyone from previous term? Like from
Yes, sir.
September?
Yes, sir.
Can you please raise your
Yes, sir.
hand? Okay. Okay, fine. Pranjal. Okay, fine. Is there anyone who knows me? No. Okay, fine. One person is there. Sanj. Okay. Sorry, Sanj. Okay, so what we will do basically in this session, this is an open session, so I will take your doubts as well as what I will do. I will explain from functions maybe. I think Vishal sir has already done that relation part, right? From week
Yes,
one.
sir. Yes, sir. Function was left.
Function was left. So I will cover those things and I will take your some general doubt into it. Okay.
Okay, sir.
So how is going your classes? So I think your first week is over, right?
Yes, sir.
Okay.
So, deadline is
Sorry?
31st.
For graded assignment or
Graded assignment.
practice? Okay. With what? 31st?
Graded, yes, 31st January.
Okay. You mean Wednesday, right? Wednesday or
Yes,
Thursday maybe?
Wednesday.
Okay. So what is the class strength in the previous class? What was the class strength?
Class strength has in this live session.
Yeah, in the live session in the previous class,
I
in the
don't know,
previous
sir.
method.
I don't
Is
know. I
there
was
anyone
not
who
there.
knows? Is the class strength is
more
visible to
than
all
100
or
people.
something? More than 100. So we have to wait for them as well, right? Is there any session running now?
No, sir.
No, sir.
No.
No,
We
Okay,
sir.
had
math
a
2
session
session.
of 10 and 7
Math.
p.m. also, but they didn't happen.
Okay, so math 2 session is running, I guess.
Next to It's not showing
Are
in
you
calendar.
Maybe, sir.
okay?
For us, any session is not run.
Okay, okay,
Max
okay, okay, okay. We'll start by 8:45. Will it find it? It is. Will it fine for everyone?
Yes, sir. Yes, sir.
Yes,
Yes,
sir.
sir.
There are more than 100 people. Let's wait for them. Then only we will start. Okay.
Sir, I have a general doubt.
Okay. Please ask.
Sir, what is a virtual reading session?
Sorry.
Virtual reading session.
Virtual reading session. What is the virtual reading session? Okay. From
It's
where
showing
you
in
have
my
heard this
calendar
term?
at
Sorry.
7 p.m. But it didn't happen.
Okay. Actually, I am also hearing this word first time, virtual reading session. I will ask to my seniors and then I'll let you know what is it exactly. Okay.
Sir, are you
If
TA or a course instructor?
I'm course instructor, but I am a newly joined instructor, so I haven't that much idea about how your course is running. Okay.
May I
So this
answer
is
what the
reading.
virtual
This
Reading,
is
sir?
reading
is?
session for those who
Can
want.
you speak one by one? Actually, it's difficult for me to recognize everyone's
Yeah.
voice. So please one by one.
No,
Yes.
may I
Yeah.
answer what the virtual reading is about?
Yeah,
This
yeah,
is
you
just a
can.
reading
That,
session for
that,
just
Okay.
that
increasing the
happens.
capability of reading or increasing in
Okay.
English communication and this.
Okay. Okay.
Is it a live session or we have to
Yeah,
study
it
on
is a
some?
live session. In this session, teacher provide 2 or 3 link in which we have to read some books.
Ah.
But it didn't happen.
So maybe they will reschedule it. Okay.
Yes, sir.
Don't worry about it.
Hello, sir.
Okay, so
Sir,
what you can do, one thing you can do, listen to me carefully first. Okay, one thing you can do. So most of the phrases are here. So I will suggest you guys, please make a WhatsApp group for your own so that you can communicate there and solve your question, resolve your doubt, whatever you have. Someone please take an initiative for you. Okay. So make a WhatsApp group or Telegram group, whatever you want, whatever platform will you want to prefer, you can do. So it's very helpful for you. Like I think this course, since this course is happening online, so you are not guide familiar to each other, right? So in that WhatsApp group you can also familiar, and if you have some doubt you can ask there as well. Okay, don't wait for any TA, don't wait for any instructor. Okay, because there are so many general doubts that you have happened. Maybe sometimes you are not like some there are some people who are very shy kind of person people, and if they have some doubts they are not willing to ask their doubts, right? So but you guys are doing same course in the same class, so you can communicate with each other and you can ask your doubt in a free mind with yourself as well, right? Same not for me either. Okay. Has the week to content for maths released for all? Is it?
No,
Please
sir.
someone
No,
answer.
sir.
No. Okay.
I was
Sir,
being
also in
uncertain
the
about
maths,
that.
there is not a supplementary content.
Yes, sir. We
Okay.
did not get the practice assignment solution yet.
Okay.
So
Okay.
for
So
me,
you
it's
will
only showing.
definitely.
Hello, sir.
Yes.
For me, it's only showing one practice assignment.
Okay. So whatever you have doubts, like whatever problem you are facing, do you have that support mail ID, right?
Yes, sir.
Yeah. So mail there. Just mail there. They will resolve your problem
Sir,
as
but
soon as
there is no
possible. Okay.
response from that side.
Actually, we did
Just
I have also sent them an email,
okay,
but
okay.
response rate is slow.
Okay, just wait some time. See, the thing is, there are so many students, around 8,000 plus students in this program, right? There are so many mails are coming to them. So it's very difficult for them to recognize each and everyone. So it takes time. Okay, so be patient and just wait for
Hello,
some
sir.
time. They will definitely reply you. Okay.
Sir, I have a doubt. If anyone can answer, you or anyone classmate. Sir, actually,
Mm-hmm.
because of my offline class work, I did not
Mhm.
attend the previous sessions. Was it
Mhm.
necessary? If anyone can tell.
See, whatever I am teaching, whatever I am teaching today, the brief part, whatever is required for today's session, I will let you know first. Then only I will start the session. Okay. So if you guys have didn't attend the session, if you have some basic idea about sets, numbers, then you can easily
Yes.
join in this session.
Previous
Okay.
instructor session is live streamed on YouTube. You can check it there.
Yeah, but
Okay.
he's asking for now, like if he wants to join the session by now, so that is why he is asking. So yeah, that session is on YouTube. You can go and watch there as well. But for today's session, yeah, I don't think so that is so necessary. But yeah, I will definitely go through that only in a brief manner. I will definitely go to them
Yes.
and then I will start the functions kind of thing because we have only functions topic, right, for week 1. That is only left. Most of the
Yes.
part is already covered. So we have sufficient amount of time for today's session. So we will go in a slow manner. Okay, we will take some
Yeah. So
example
actually,
away
I have complete.
and
Actually, I have completed
Mhm.
all the week 1 and week 2 work which were provided by IITM on the
Mhm.
portal. But actually, I
Mhm.
didn't attend the live sessions that happened. So,
Okay, okay, fine. It will be fine for you. It will be fine for everyone actually. Okay, don't worry.
yes.
I'll take that. Okay. Is there any general doubt?
Sir, I've
So
just completed the
welcome,
set. So
welcome to all of you. Just a minute. Welcome in the Maths BS
Excuse
program.
me, sir.
Yes.
Sir, where I found class calendar or class notifications.
I think that thing you may ask to TA and they will let you know in a precise way because they are also a student. They know how the thing is going on. Okay.
Okay, sir.
Actually, I don't have that much idea about this course. That is why I'm saying.
Hello, sir.
Yes.
My academic calendar not show any meeting.
Okay. Your academic calendar, there is no meeting is showing in your academic calendar, right?
Yes.
Okay. Okay, then ask to TA for that regarding. I think there are something where you have to allow that kind of thing. Okay, or you can ask to your classmates as well. They will let you know from where they get the access, from where they get that kind of thing. They will let you know.
Okay,
That is
sir.
why I'm saying, na, that is why I'm saying just make a WhatsApp group and communicate on that group itself. So there may be so many general
Done.
doubt that doubts will be resolved on that group only.
Okay, done, sir.
Okay.
sir, I have a
Just
general doubt.
yes.
I've just completed the sets. So should I leave the session or continue?
You can continue. You can continue. No issue. I already told you. No, I will take that kind of thing as well. In briefly, I will touch. Okay. Okay. Shall we start the session?
Yes, sir.
So the participant is more than 102, including me. Okay. So what we will cover in this session, basically, our mota topic is functions. Okay. So what is function basically that we will discuss in this session. So someone is asking if you click on each course academic, yeah, that you just read. Okay, so we will discuss about function. So I am again asking, am I audible to all?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Just a minute. What happened? Pen is not working. Okay.
Hello. Excuse me, sir.
Yes.
Sir, can you tell, sir, in my dashboard, graded assignment in CT subject graded assignment can't show, sir.
Okay. So your graded assignment is not showing in your
How I
dashboard,
fix it,
right?
sir? Yes, sir.
Okay. Which course?
See,
City.
computer thinking and maths are also the big two contents can't so.
Okay. So, okay, don't worry about it. Just, did you send a mail to a support course?
Yes, sir, but
Support team?
support team
Okay,
can't
just
reply.
wait. Okay, just wait for some time. Do you have any contact to your TA?
Hello.
Do you have any contact of TA?
No,
No,
sir,
sir.
we don't have any TA
No,
Okay,
sir.
contact.
okay. So,
Can't,
okay,
sir.
so okay. I'll take this kind of thing. I will let you know the senior authorities. Okay, about
Sir,
that kind of thing.
sir, please contact and fix it, sir.
Okay. I'll do that.
Because sir, week second is started, sir, after some
Yeah,
days.
yeah, yeah. I'll understand your concern. Okay, I'll inform them. Okay, they
Yes,
will
Sir,
they will
I
sort out.
I have one more doubt, sir.
Yes.
Sir, in practice assignment, sir, practice assignment can't submit button here. Only check answer button is here, but submit button is not here. It can't submit.
Okay.
My
That thing
answer.
I will do. Is that thing is
that
happening for
that
everyone?
It's the
And
same
sir,
for
one more
everyone,
thing.
sir. It's
okay,
Same
same
that
for
for
everyone.
that
everyone, na?
We
if
cannot
You
submit.
can
Okay.
only check the
Okay.
answer.
So just a minute. The thing is, practice assignment is only for your practice. Okay, that is no kind of submission. At least I know that up to this kind of, I have that kind of information. Submission
Sir,
part
yes,
is only have that graded assignment.
yes, sir.
Yes,
Only
But
submission
we
is
sir,
only
can
for
practice
submit
graded.
assignment
graded
has a
assignment.
bonus marks, so that's why we.
Okay. Okay.
Even
I
if
will.
you click on check answers,
Even if
that
you
all
check
that
the
sir,
will
it
also
answer,
can't make
submit.
any issue, sir, na?
No,
no, it's
just
the
no,
same.
no. That will be resolved. Okay, that will be resolved. I will ask and I will let you know. Okay,
One
or
more
I
thing,
If
sir.
will
you are going to
tell
Sir,
check
you.
all the answer before the due date of that practice assignment, then your bonus marks and whatever thing you're talking about will get
Yes, exactly.
you'll get
Okay.
according to whatever.
okay. Sir, one more thing.
Okay.
Supplementary content has not released for city and maths also.
Okay. So just listen to me carefully what I'm saying. Okay. Whatever problem you are facing, in the end of the class, please write those problem in the chat box so that I'll directly copy here and then I'll paste to them. Otherwise, I will forget after the class. Okay.
Okay, sir. Okay.
Okay. In one list, please take all over problem whatever you are facing, or I will write here only. Okay. In the note, please say one by one. I will write here only and then I will let them. Okay.
Okay, sir.
Shall we start the session now?
Yes, sir.
Okay.
What's going on?
Yes.
Yes, sir.
Okay. So one thing that I want to know, please, whenever you have doubts, then only you can unmute yourself, or you just raise your hand. I'll take your doubt. In between the class, please try to mute by yourself. Okay, don't unmute yourself in the class. Don't make so much noise in the chat box because it will like I will distract on that, and then there may be something that will happen. Okay, I don't know what. So I don't want to distract on the session. Okay. So it's kind of interaction session, kind of one-to-one interaction kind of thing. Okay. So you support me, I'll support you. That kind of thing will happen. Okay. And also one more thing, I'll always wants to responses from your side. Okay. Please respond whenever I am asking something. Okay.
Okay, sir.
Okay, sir.
Yes,
Okay,
sir.
please respond. Please mute yourself. Please unmute yourself and then respond. You are free to respond, but please don't make so much noise. Otherwise, section will be interrupted and we all get some issue. Like I will forget some many things, and there will be kind of thing will happen. Okay. Okay. So let's start the session. So did you heard this word set? We'll start by set. Okay. What is set? Can someone tell me?
Collection of well-defined
The
items.
collection of well-defined items.
Collection of well-defined
What do
items.
you? Okay, so someone is saying collection of well-defined objects, right?
Collection of well-defined objects.
Okay.
Collection of well-defined objects or well-defined
Or-
collections of objects.
Objects. It's a collection
Okay.
of
Someone
objects.
is saying, okay. Two definitions are coming. First is collection of well-defined object, and second is well-defined collection of objects.
Sir, it's just a collection of objects.
Okay. Someone is saying, sir, collection of objects. Okay. Okay. So let's do poll. If you are agree with 1, please type 1. If you are agree with 2, please type 2. If you are agree with 3, please type 3. Let's see. Okay. Let's go through one by one. Okay. Let's take the last definition first. What do you mean by collection of objects? I hope you will understand after this thing, after this session, what is exactly said, what happened to this. It is live or stream. It is streaming on YouTube. Someone please check and please let me know if it is not. Okay.
Yes, it's streaming, sir.
It's streaming, right? Okay. So what do you mean by collection? Can someone please unmute yourself and then let me know what is collection? Anyone?
Grouping, sir. Grouping of objects.
Grouping, right? Okay, let's think about a story. Okay, I will tell you a story. So, did you went to the medical shop?
Yes, sir.
Everyone?
Yes, sir.
Okay,
Yes, sir.
suppose this is
sir.
your medical shop.
Yes,
One
sir.
more thing, my drawing skill is too bad. So please. So this is the shop owner. Okay. This is your medical shop. Yep, the window and this is gate. Okay. And here this is counter. Okay. So whenever you are going with like a medical shop, you have observed that if this suppose some John, this person name is John. John is went to the medical shop and he is asking for some medicine like paracetamol. Okay. So whenever you are asking for some medicine, you have seen this person, suppose this is person, what to say, Rohan. Okay. This Rohan, what he will do? He will go to some place and he will check a box. Okay. And what he is doing, he just took the exact medicine into this box. He will take the paracetamol from this box and he will give it to them. Right?
Yes, sir.
If you are going with any medical shop, any medical store, that thing is happen. Right? He don't.
Yes, sir.
Now, one more case. Suppose there is a box. Okay. And in this box, there are so many medicines like paracetamol and Disprin. Okay. And so many medicines are there. Right? So many different type of medicine are there in this box. Okay. Now, if I am again asking to this Mr. Rohan for a paracetamol medicine, what he will do? He will go to this box. The next time he will go to this box and he will find to that paracetamol medicine in the entire box, right?
Yes, sir.
Yes, sir.
Right?
Yes.
But what thing is happening here? What thing is happening here? In the first case, the time that he has taken to find a paracetamol, that was minimum, right?
Yes, sir.
Yes, sir.
Yes.
But in this case, he will go and he will he will find where is paracetamol, where is paracetamol, or after some time he will be frustrated.
Yes, sir.
But this is also a collection.
Yes, sir.
Collection means we are collecting the values.
Yes, sir.
Okay, in Hindi we will say we are taking some values, like we are हम उसको क्या कर रहे हैं, संग्रह कर रहे हैं, मतलब हम collect कर रहे हैं, right?
Yes, sir.
We are collecting all the values. We are collecting all the balls, or we are collecting all the medicine in one box, right? This is also a collection. This is also a collection. This is also a collection. So why we need collection? That is important. Why? Because if we are not going to collect the values, it's very difficult for me and for everyone to find that kind of thing.
Yes, sir.
Right? In the home, you have seen what mummy will do. Mummy will collect all the winter clothes some other place, in some other place, all the daily sorts, like sorts kind of thing, whatever daily uses clothes are there, she will collect from there. Okay, and every section she will divide for each and other clothes, right? Or you have seen in the kitchen, there will be some specific type of jar for salt, there will be some specific jar for chili, and there will be some specific salt for different masalas, right?
Yes.
Why she is doing that kind of thing? She didn't know mathematics, right? But why she is doing?
For organizing
the thing, and for
Convenience.
as well, for reducing her time. Otherwise, what will happen if she will put all the things in one box? Okay, so what will happen? She will just on the gas. She will put a pot, and she will making some. She will confuse. Exactly, she will confuse.
Accessibility
where
is
is the
not
salt? Where is the chini?
easier.
Yeah.
Accessibility also
Yeah,
becomes
exactly. So, do you know why we need this collection?
to pick
Why?
the object
Why I need it?
in a right manner.
Exactly. Why needed?
Sir,
Okay.
to reduce our time.
Reduce the time.
Exactly. Why needed? Why needed that thing you have understand? Why needed you understood?
Easy
Okay.
accessibility.
Now, we have collection. Okay. We understood why we need this collection. Everyone understood this thing?
Yes.
For reducing our time, for compatibility. Okay. There are so many things. Okay. So that our work will be easy. Whatever thing I want to find, I can find easily. Right?
Yes, sir.
Now, again, let's talk about this collection. What kind of collection we need? Okay. So collection of object, this thing understood. So here two terms are there. Collection of well-defined object and well-defined collection of object. There are two words. So what do you mean by this well-defined object?
Collection
Sir,
of
previously, in the first case, the collection was well defined, but in the second case, it was not well defined. Different kinds of medicines were put in the box.
in an
So,
Okay.
when a common
Sir, in
kind
first
of
case, the
medicine,
objects are well defined, and in second case, the collection is well defined.
well-defined objects
Okay.
in the sense
So
the objects are
talk.
ordered.
Okay.
Ordered or
So
unordered.
let's talk about. Okay, just listen to me carefully. Let's talk about this well-defined objects. What do you mean by? Okay. So if I am talking about this paracetamol value, is there any possibility that this paracetamol medicine will not be defined? Or if I am talking about any object, is there any possibility that if that object is exist, that object will not define?
No, sir.
No, sir.
No, sir. Right? If something is exists in this world, that should be well defined.
Yes, sir.
Whatever
Yes,
thing
sir.
it is. So the first definition will not be happen, because well-defined object and object both are same. What do you mean by well-defined object? Everything is same. Now, if something is exist in this world, if I am taking some collection of object, that object will be well-defined always. That is why I am taking the collection, right?
Yes, sir.
There is no such possibility
Yes, sir.
that, yeah, object is there, but that object is not defined. Suppose I have pen and I don't know what is this pen. That kind of thing
This is
happen.
absurd.
So this definition will not work. Now let's move to this definition. Well-defined collection of objects. What do you mean by this well-defined collection of objects?
The collection of things is well defined.
Okay, so we have two definitions right now. This is Discord, right? The first
Yes,
one
sir.
will not work. Now we have one. We understood why we need collection. Now we have two definitions. First one is well-defined collection of object. The other one is collection of object. Let's discuss about this third one, collection of object. Okay. So if I will ask you guys, who is your favorite cricketer in Indian team? Okay, just give me two names.
MSD.
Sir,
Virat Kohli.
MS.
Mahendra Singh Dhoni.
Virat Kohli. Okay.
Virat
Some
Kohli.
other person?
Ravindra Jadeja.
Gautam Gambhir.
Mohammad Sharma.
Rohit Sharma.
Ravindra Jadeja, RJ.
Rohit Sharma.
Rohit
Hardik.
Sharma. Okay, Rohit
Suresh
Sharma.
Raina.
Okay. Another Hardik Pandya, someone is saying. Or
Mohammad Raina.
Mohammad Sami is
Shubman
saying.
Gill.
Surya Kumar Yadav.
Okay. Sky is saying someone.
Mohammad
Suresh
Shami.
Raina.
Gautam Gambhir.
Ashish
Okay,
Nehra.
let's take a bowler, man. Let's take some bowler.
Bumrah.
Now, observe here. This is also a collection of your favorite cricketer. Suppose Aman is saying, sir, this is these two players are my favorite cricketer. Sohan is saying, sir, this should be my favorite cricketer. This is my favorite cricketer. Ram is saying, this is my favorite cricketer. And Isan is saying, this is my favorite cricketer. But what thing is observe? What we have to observe here. Whatever collection we are taking here, the element, the member of collection is different for each and every person, right?
Yes, sir.
Just see.
Yes, sir.
This is also a collection of favorite cricketers. 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 But the thing is, when the person is changing, even I am talking about favorite cricketers, the collection is changing, right?
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Do you observe the thing?
Yes, sir.
Whenever the person is changing, according to them, the collection is changing, right?
Yes, sir.
It's just like in a kitchen, if mummy is coming, for mummy, salt is salt. Okay. But if your sister is coming, salt become chini. Sugar.
Yes, sir. Yes.
But we don't want that kind of thing.
Yes.
We don't want that kind of thing. We want salt as salt. Otherwise, kheer will be what?
Salty.
Salty, exactly. Kheer will no longer tasty, right?
Yes, sir.
Okay, so that's the thing. If even this is a collection, I am not saying this is not a collection. This is a collection. But what thing is happened? As persons are changing, my collection is changing accordingly, right?
Yes, sir.
So what we need here? We have to define something. For that, this collection should be changed even if person are changing frequently, right? What
Yes, sir.
we need salt as salt. Okay, so for that, what we will do? We will take a jar where salt is there and we will stick a sticker and write it as salt.
Salt.
So by this manner, for my sister, that salt will be salt only. It will not become sugar, right?
Yes, sir.
Yes, sir.
Yes, sir.
Then kheer will be tasty.
Yes, sir.
Yes.
Yes,
Right?
sir. Obviously.
Understood the thing? So we need something for that. This collection should be same for everyone.
Yes.
Yes, sir.
So for that, we need this word well-defined. So what does this mean? Well-defined. It means that whatever collection I am taking, that collection should be well-defined. What does this well-defined word mean? It means that the collection should be same for each and every person. Okay. Wherever he will live. Just like if I will ask you, just collect all the vowels in the English alphabet. A, E-I-O-U. Okay, this is also a collection. What I took? I took a small alphabet of English literature, the vowels. Okay.
Yes,
So
sir.
is this collection will be different for anyone?
No, sir. No, sir.
No,
No,
sir.
It will
sir.
be uniform
Right?
for
So
everyone.
what is set exactly? What is set exactly? It's a
Collection of objects.
well-defined collection of objects.
Yes, sir.
Well defined.
Collection of object. Okay? Understood the thing?
Yes, sir.
Yes, sir.
Is there any doubt in this definition? You understood why we need collection? Okay? What is well-defined means?
No, sir.
Did you understood everything?
Yes,
Yes,
sir.
Can you
sir.
repeat the example of cricketer one?
Hello.
Yes,
Okay. So in this example, in the cricketer example as well, if now here what thing happened here? Here the collection is different for according to the person, right? But if I will ask you, just give me two cricketers' name. Okay, who hold? Okay, let's change this. Just give me the collection of. Give me the collection of all the captains of Indian cricket team. Indian cricket team. Okay, so what you have to do? You have to take a bag and you have to put all the names of the Indian cricket, all the names of the captains of Indian teams. So that collection should be same for everyone, right?
Yeah, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
That cannot be changed.
No, sir.
Yes.
Yes, yes.
At least by this time that will not change. Okay.
Yes,
Otherwise, someone will stand and he will ask me, sir, there will be possibility that after some time Hardik Pandya will become a captain of Indian cricket team.
Yes, sir.
Okay. There will be possibility, but at this time, at this point of movement, the collection should be same. Collection will be same, right? It won't
Yes,
be
sir.
changed. Okay. So understood the set concept. Okay,
Yes,
so
sir.
we will
Yes, sir.
not move so many, we will not invest our so many much time in this. Okay, so let's quickly move to Cartesian product. Cartesian product. Okay, I'll write the definition. Everyone knows, I hope. The set is the main conceptual thing. That is why I explained that much here. So the speed is fine, or you need to be more faster from my side.
Fine, sir.
Please let me know
Sir,
that.
you can be a little bit faster so that we can cover each and every topic.
Yes,
Yeah,
sir,
we
please.
will cover. Don't worry. We will cover. It will like the session. We have no time constraint because this is the last session for today.
Yeah.
Maybe there will be no such session after 10:30. At least I am expecting this thing. Okay. Okay. So what is Cartesian product? Suppose you have two sets, A and B. What kind of sets it is? They are non-empty set. What do you mean by non-empty? At least there will be some elements in the both set. Okay. Then the Cartesian product, I think you have the definition of Cartesian product. Okay. That is why I am writing all the words in a short form, because
Yes,
I don't want to invest the time on that. Is represented as A cross B and defined as A cross B equals to the pair form AB, such that A is coming from this bada A set and B is coming from this big B set B. Okay, this is the definition of Cartesian product. right?
Yes, sir.
Okay.
Right, sir.
After
Yes, sir.
that, okay. After that, you have heard about this relation word. So
Yes,
what
sir.
do you mean by this relation? This relation R is nothing but it is a subset of this Cartesian product A cross B.
Cartesian product.
Yes, sir.
Right? This relation has already done. So after that, the binary relation is come to the picture. What is binary relation?
Sir, so relation is always a subset of any type of Cartesian product. It is always a
Yeah,
relation.
Yeah. So here, just see here. Okay, just see here. Here you have two sets, right? A and B, right?
Yes, sir.
There will be possibility that this A and B will be equal. There is a possibility. There will be
Yes,
some
sir.
case or that this A and B will be
Yes.
equal. So in this case, this R will become your subset of A cross A.
Yes, sir.
So in this case, we will say this R will become our binary relation.
So it
Yes,
is
sir.
necessary
Understood?
to be relation of subset of anything.
Sorry.
Sir, one
Your
day
voice
if the
was
two
break.
sets are equal, we will get binary relation now.
Yeah, in this case, if A and B, this B will become A. Like if R is your subset of A cross A.
Okay.
If R is a subset of A cross A, then we will say this R will become your binary relation. Okay.
Okay. B becomes A.
Easy. Okay. B becomes A, no? It's just B
B
is equal to
A.
Excuse me.
Because this B is independent to A, this A is independent to A, B can be anything, A can be anything except empty. Okay. So there may be possibility that this B will become A for some time. So in that case, when this B is equal to A, then this R will known as binary relation. That's it. We will introduce one more terminology as binary relation when this B will become A. That's it. There is no
I
rocket
am
science.
saying that the relation is always a subset of anything.
No, it's not a subset of anything. It's always a subset of Cartesian product of two sets.
Okay,
How
sir,
will
I
you say
got
that definition? Okay, that cannot be subset of anything. It does not make any sense, right?
Okay, sir.
So if A and B are not equal, then binary relationship.
It's just a relation. It's just a relation.
Oh, all right. Thank you.
In that case, it's just a relation.
But always it will be the subset of Cartesian product of the two sets.
Yeah, exactly. That is the definition of relation.
Okay,
No?
okay, sir.
That is the definition of relation. It will always be a subset of A cross B.
Hello, I have a doubt.
So it means the every Cartesian product is a relation.
Yeah, exactly. Because the Cartesian product is itself a subset of.
Hello, I have a doubt.
Yes.
Thank
Yes.
you.
Actually, since the empty set is the subset of every possible set that there is, what
So
relation
empty
would it
set will
correspond
also
to?
become a relation.
What kind of relation would it look like? Let's say
Okay,
we
let me tell you the example. Suppose you have set A is equals to 1, 2, and 3. Okay. And B is equals to what? -1, 2, -1, -2, and -3. Both are relation. I am defining a relation as x square. What it does it means? It means that you have x here and x square here. Where x is coming from your A and your x square will go to B. Right? Take 1. What will be its square? 1. So
One.
what will be the pair? 1, 1. Take 2. What will be the pair? 2, 4. Take 3. What will be the pair?
3, 9.
3, 9. Okay. If I will consider this to say, in the entire Cartesian product, is there any pair like this?
No, sir.
So for this to set, this relation should be empty.
Yes.
It will be empty. But this is itself a relation.
So there isn't any constraint on it being
There
a
is no constraint. There is no constraint. That is why we are saying that it is just a subset of Cartesian. And phi is also subset of Cartesian product. So it will become a relation. See, I have given a relation.
Okay, thank you.
Okay, fine. Easy. Okay. So there are some kind of thing, some types of relation I am not going to touch. I need only this definition of relation for my function. Okay. So let's start the function. Okay. So before starting the function, I'll give you some.
Sir, please, if whether you will explain the types of relation, subjective, bijective.
Surjective, bijective.
Yes, sir.
That is the part of functions.
Function. Sorry, that is the relation, equivalent,
Yeah.
reflexive and
Yeah, that,
transitive.
okay. Okay, actually, okay, I will explain that thing as well. Okay, can I explain functions first? Because we have
Okay.
only function.
Okay, sir.
After
Yes,
completing
so
this, I will explain those things as well.
Okay.
Because
Okay, sir.
here are some,
Okay.
because here are some people who already know that concept. Okay, so
Okay,
and they
sir.
are waiting for functions only.
Okay, sir.
And you are also waiting for functions. So we will
Yes,
cover
yes.
functions first, and then we will discuss later.
Okay, sir.
Okay, because
Okay, sir.
that thing is not important for function right now.
Okay, fine, sir.
Okay, so let's start. Let's start the functions journey. Are you ready? How's the Josh?
Yes, sir.
I am Vicky Kausal's friend.
Hi, sir.
Okay. Okay, so
Sir,
if I will ask, yes.
will every binary relation be symmetric? Because of
That we will cover, okay, after the functions. That symmetric, antisymmetric, asymmetric part we will cover, okay? Don't worry. Just wait for some time. Let's start the function first. Otherwise, class the time will go and we will not able to cover the concepts.
Yes, sir. I have also doubt in set theory.
Okay. Collect your doubt. I will let you.
Okay.
Okay. So what is function basically? Let's forget about this word function first. Okay. So
All
if
the
I will,
relations or functions.
we will discuss. We will discuss what is it. That is why I have explained the relation part. Okay. So I am saying, suppose I have a box. Okay. This is called as magic box. Why I am saying it's a magic box? Because what this box is doing, whatever thing I am entering in this box, this box is giving me a different thing. Just like if I am entering 1 here, what he is doing, he is entering, or what he is doing, he is always multiplying the number by 2. What kind of box it is? Whatever input, whatever thing I am throwing inside this box, the thing is going to be double. You are getting my point?
yes, sir.
Just like if I am putting one ball inside this, if I am putting one ball inside this, it is giving me 2 balls.
Output is the two balls.
Okay, let's take another example. Suppose I have a chips making machine. It's a chips making machine. Lay's making machine. And it is doing that kind of work. I am putting some potatoes inside this chips making machine and I am getting some crispy chips. No. We are not going to be, this is not a polity class, so we will not discuss that kind of thing, okay? Please. Okay, so I am taking some potatoes. This machine is taking some potatoes. If I am putting inside one potato, suppose it is giving me 4 chips for every potato. Okay, there are only 4 blades, suppose. So what this machine is doing actually? This machine is taking something inside him and doing some kala jadoo into it. Okay, and giving me some chips and some outputs, right?
Yes, sir.
Right? What
Yes,
kind of
sir.
thing it is? It is taking something and giving something.
Yes, sir.
Just like bulb, electricity bulb, it is taking energy as an electron and giving me energy as light.
Yes, sir.
That
Yes,
that
sir.
is also a machine, right? If we will ask
Yes.
for real life example, you are getting my point. So what is this thing actually? What is this thing? So if I will ask you to make a machine so that whatever thing I will entering in this machine, that thing will be multiplied by 5. Okay, whatever number I will apply, whatever number I will give this machine. Suppose I have the collection of numbers. What kind of number? It is a set of natural number. Okay, it is a set of natural number. So someone is asking also graded assignment of computational thinking are not showing in my dashboard. Okay, I will let them know. Okay, Rajmani, don't worry about it. Okay, so what kind of machine I want to make? I want to take numbers as an input, okay, and multiply by all the numbers by 5. So it will give me some values, right? Suppose I am taking 1 as input, and what I will give after entering this, after passing this machine, I will get 5. If I am entering 2, what I will get? I will get 10. Okay, suppose I have a small collection. 1, 2, 3, 4. Okay, 4 members are there in this set S. Okay, same machine is there. This machine. Suppose this is machine A, or for instance, we will say this is machine A, F. Okay, this is machine. What this machine is doing? All the number. If I'm one will go inside. Okay, take here. One will go inside. I will get what? 5 into 1, which is 5. If 2 will go inside, I will get 2 into 5, which is 10. 3 will go inside, I will get 15. 4 will go inside, I will get 20. Right? You are seeing now what thing is happening here. Basically, what this dabba is doing, this is taking some values. Hi, Narendra. This is taking some values and giving me something, some outputs kind of thing. Right?
Yes, sir.
Okay. One more question I will ask.
Sure, it's
Is there
applying a formula.
Okay, so this dabba will work for each number, right? Whatever number I will give into this dabba from my this set, this will multiply that number by 5, right?
Yes, sir.
This dabba will
sir.
multiply that number by 5. That thing will
Yes,
happen.
yes.
Right? Is there any possibility that any number, for any number, this function will not work? Yeah, or this dabba will not work?
No, sir.
No, right?
Zero.
Please mute yourself.
No, sir.
Someone, please mute yourself. Someone is talking in the phone, I guess. Okay, if okay, thank you. Okay, so what I was discussing? I was discussing that there is no such possibility that there will be no such number in this set. For that, this machine will not work.
Yes, sir.
No, sir.
Right?
It will
Sorry.
work for every.
It will work for
Yes,
everyone.
sir.
Okay, Gauri. So what I am saying, I have a machine. What this machine is doing, this machine is taking the values from this set and the machine is multiplying that number by 5. So I am saying till now I have said this machine will work for each and every number. There is no such possibility that this there will be no such number. For that, this machine will not work on that number, right? So
Yes,
it
sir.
means that
Right,
the
sir.
first thing is this app will take every input from this set is right. It can take any input from S, right?
Right, sir.
One more observation.
Yes, sir.
If I will give you some input to in this F, if I am giving you some inputs to this F, we will always get an output, right?
Yes, sir.
Yes, sir.
Right? there is just like in potato making chips. If I will
Yes,
give
yes.
you a potato, if I will throw the potato into this chips making machine, I will definitely get some chips,
Yes, sir.
Yes, sir.
Like
right?
machine like a
Yes.
Rahul Gandhi potato machine.
Please don't comment on this, okay? I am requesting you, please don't. We are not playing with politics. We are playing with maths right now. Please try to understand the concept. Okay. So what kind of thing is happening here? If I am giving a potato, we are getting some chips, right? There is no such possibility that I am giving potatoes and there is some rats and he eat the potato and I did not get any chips. That kind of thing is not happening here.
Yes, sir.
Excuse me, sir.
Yes, sir.
Yes.
So can you explain the topic of codomain from this diagram also?
Yeah, I will explain. Just wait for some time, okay? Just be patient.
Sir,
Just
in
wait for
this
some time.
chip making machine, what's acting like a function?
Sorry?
Number of cuttings,
Yeah, number of
like
cutting, number
number of
of blades you can say, number of blades you
yeah,
can say.
that could be a
Okay.
function.
Yeah, that kind of function will be required here. I am just giving you a brief idea about function, what function is
Yeah.
doing actually. I did not mention that, but I firstly said, forget about this word function. Okay, we are working with dabba. Sir, आपका नाम क्या है? Anyone know? Actually, I am Arpit Amrate. Okay, my name is Arpit. Thank you. Okay. So what thing we have observed here? Let's coming to the point. Okay, what thing we have observed here? We have observed that no, it's a second or third class. Maybe it's second most probably. Yeah, that thing I will cover here. Don't worry about it. Don't worry about it. Okay, so what we have observed here? We have observed here. Every member will part of this machine, right? For this machine will work for every member. And the second
Yes,
thing
sir.
is, if I will give you the input, if I will give the input, I will get the output, right?
Right, sir. Yes, sir.
Yes, sir.
So remember these two things, okay? We will discuss soon. Okay. So what is function actually? So in this case, just like this case, function is nothing but it's a magic dabba or it's a magic box who is taking some output, taking some input and giving me some output. Okay, taking some inputs and giving some outputs. You are getting my point? What kind
Yes,
of thing
sir.
it is? It's a magical
sir.
box which is taking some inputs and giving some outputs, right?
Right, sir.
Yes, sir.
Okay.
Yes,
So, okay. So from that set where this function is taking input, or from which set this dabba is taking inputs, just like in this potato making machine, there is a collection of potatoes, right? Some sweet potatoes, or you will say some good looking potatoes. I think you have seen that ad of Ashirwad Atta, I guess, right? So in that ad, they will say we are choosing one by one grain, right? One accurate grain. That kind of ad, did you seen? No.
Yes, sir.
No, sir.
Yes, sir.
Okay. Let it go.
Okay, sir.
So in that ad, what they will they will discuss about that our atta is very good because we are choosing each and every grain by our hand only, and we are making atta by the did you seen that chakki kind of thing that
Sir,
will be
Ashirwad
operated
Atta.
by hand? Yeah, I'm talking about that Ashirwad Atta. That was like that ad was around 2012 or 2010 maybe. Like on this time, though, no one is watching TV. Everyone has mobile in their hand. So I think the ad thing is not happening. But if you are watching
I
the
was
TV,
seeing the
so
ad,
you have
sir.
seen, right? So that kind of thing. So in this set, this potato making machine, for this potato making machine, there is a set as who has some good looking potatoes, some sweet potatoes. Okay. So for this machine, we have some collection where potatoes are there, right? There is no such thing so कि there is no such thing कि जादू से कोई potato आया और अंदर चला गया, नहीं, right? There will be no kind of magic from where potato is directly coming inside the chips.
No, sir.
Right? There will be some set, there will be some collection which has some sweet potatoes, some good looking potatoes. Then only this chips making machine can taking inputs, right?
Yes, sir.
For this case, this function f has some collection 1, 2, 3, 4, collection of 1, 2, 3, 4, right? Right? I'm requesting you, whoever is talking with mobile, please mute yourself and then talk. Please don't disturb the class. Okay? Okay. So what is happening here? Here, the machine is taking some inputs. So from where the machine is taking input, that collection or that set is known as domain. You are getting my point? From where the machine is taking inputs, or you can say input set. Input set. This input set is known as domain. Yes, Naren. Okay. And from where it is giving output. Similarly, whatever output is the magic box is generating, the collection of out, there will be some collection where output will come, right?
Yes,
Just
sir.
like in this potato making machine. In this potato making machine, suppose there is a pot where chips are collecting. Right?
Yes, sir. Yes, sir.
So in this case, where we are getting output, in which set we are getting output, that set is known as codomain. You got my point?
Yes, sir.
Yes, sir.
What? From where the machine is taking input, that input set is known as codomain. From where the machine is giving me output, that set is known as codomain. Okay?
Yes, sir. Yes, sir.
So two things we have discussed here. What are those two things? There is a set, suppose A, S, S1 we can say, and there is
Yes, sir.
another set S2. Okay,
Yes,
and
sir.
there is some machine is happening here, which is known as function or denoted by F. And here some inputs. Okay, and here some outputs. Suppose inputs are my 1, 2, 3, 4, 5, 6, 7. And outputs are my 2, 4, 6, 7, 8. Okay, and here. So what? So observe here, by this two statement, F will take every input from S. It means that every member of this S1 will relate by some manner from this S2, right?
Yes, sir.
Right, sir.
It means
Yes, sir.
that every member of this S1 have some output,
Yes, sir.
and that output will be unique.
Yes, sir.
Yes,
Right?
sir.
Why it will be unique? Just like in this example, if I will give the output, I will get the if I will give the input, I will get the output, and that output will be unique. Will be unique. That kind of thing is happening here. Why? Because if I am throwing 1 into it, I am getting 5 only. There is no such cases where I am throwing the 1 and I am getting supposed to. No such case will be happen here, right?
Yes, sir.
So what kind
Yes,
of thing
sir.
is happening here? Each member of this S1 will have an output, okay? And that output will be unique.
Yes,
Got
sir.
my point?
Yes,
my
yes,
point?
got it. Got it.
Got it? Okay. And this set is known as input set, or you can say domain. We will use
Domain.
mostly domain for that, and that set is known as output set. Output set, or you can say codomain. Okay, but just
Hello.
just listen to me carefully. Okay, here we are saying for input set only. There is no constraint on output set, right? Suppose in this chips making example, I am throwing the potatoes and I am getting chips in this jar. But there is a possibility that this jar already has some chips before throwing the output. There is a possibility, right?
Yes, sir. Definitely.
There is a possibility that this jar already has some chips. After that, we are throwing the potato and we are getting the chips. There may be
Yes, sir.
possibility that.
Yes,
Right?
sir.
So there is
Yes.
no constraint on
Yes,
this output
sir.
set,
Yes.
right?
Yes.
Right?
Yes, sir.
Right, sir.
Okay, but what thing is happening? But I am getting some new chips into this output, right?
Yes, sir.
Into this output set or into this codomain set.
Yes,
I am getting
sir.
some new thing.
Yes,
Okay,
sir.
so that new thing is
Yes,
known as
sir.
range. You're getting my point?
Yes, sir.
That new thing is known as range.
Range.
So
Yes,
what is
sir.
range exactly? If I am giving some input or I am getting some output, I am getting some output. So whatever thing I am getting, that collection of those things is known as range. Got it?
Yes, sir.
Okay. So here three terms are there. First
Sir,
is
what is the
domain.
difference between codomain and range?
I will let you
Can
know.
you repeat?
Yeah, I will. Domain, codomain, and range.
And range.
Okay, three terms. Domain is nothing but input set. It is easy to understand, right? From where this function is taking the values. Input set. Codomain is nothing but output set. Output set. From where this function is giving me the output. Just like that. Just like this potato making example, this potato chips example. Suppose this is a jar. It has 5 chips. It already have 5 chips. Now I am throwing one potato and I got 4 chips extra. So how many chips are there in this pot? We have 9 chips right now, right? But from the output, we have only 4 chips, right?
Right.
Because 5 chips are there before throwing the
Already present.
potato. Yeah, it was already present in this pot.
Sir, is range a subset of codomain?
That's what
Yeah.
I'm trying to say. Right? Here, this whole thing, this 9 chips will become your what? Your codomain. This 9 chips will become your codomain. And
Yes, sir.
this 4 chips is coming extra. So
Yes, sir.
this 4 chips will become a subset of this 9 chips, right?
Yes, sir.
Yes, sir.
Right? So
Yes, sir.
always range is always a subset of codomain. So what is this? This is output set. It means that where the function is giving me output. What is range? Set of all output. Right? It means that I am giving sorry. Someone is saying something.
So your screen is blank.
Is it visible now?
Yeah, it's not blank.
Sir, it's visible only.
Yeah, it is
Yeah,
Visible,
it's
sir.
visible.
Sir, maybe it's network issue.
Okay,
Yeah, most
you
probably.
just refresh yourself, okay? You just refresh yourself. Okay, so you understood what is domain. So domain is basically the input set. What is codomain? Codomain is nothing but it's a output set, and range is what? Whatever outputs I am getting, it will become your range. Okay, let's take an example. Suppose you have f, which is defining from A to B. Now we will discuss what is A. Suppose this is your set A, 1, 2, 3, 4, 5, and this is your B. it has number 1, 2, 3, 4, 5, 6, 7, 8, and blah, blah, blah. So many numbers are there. And f is defined. This is your b. Suppose 1 is related to 1. Thickness is too much. Okay. 2 is related to 2. 3 is related to 5. 4 is related to 4. It does not mean I'm talking about function. Okay. I am just saying this function is taking one value and giving me output as 1. It is taking 2 and it is giving me output as 2. It is taking 3. It is giving me output as 5. It is taking 4 and giving me output as 4. It is taking 5 and giving me output as 7. Okay. So for this case, how will we write? How we will write? We will say f of 1. What does it mean? It means that this is box, and here inside 1 it means this box has taken 1 as input. And this is or we can say this is the function, and no Anurag, I will say now, just wait for some time. Okay, I will say what does what is the basic difference between range and codomain. Don't worry. So right now I am just explaining what is representation kind of thing I am just trying to say. Okay, so what is this means? It means that this function f is taking 1 as input and equal to what? This f of 1, it means 1. What this one is? This one is output. Okay, whatever output we are getting. Or we will say this one is a image of this one. Similarly, what will be your f of 2? Yeah, I will explain, Palak. It will be 2 only.
Yes, sir.
Right? What will be your f of 3?
5.
5. What will be your f of 4?
4.
4. What will be your f of 5?
7.
Okay. You what is your input set, or you can say domain?
Yes, sir.
It is A, right?
Yes, sir.
Yes, sir.
Okay. What is your output set?
Set B.
B.
Codomain, you can say. It is B, whole B. And what is your range? See,
So
from
whole
here,
set B.
not whole set, because 3 is not the member of
3
range.
is not a...
Okay, so just look at here. This whatever I am getting here, but in this set there are some members who are not the part of this entire thing, right? There are some extra members which are not the part of this kind of function and this kind of thing, right? But they are still inside this B, right?
Right, sir.
So are you able to see the difference between codomain and range? So what will be
Yes,
your
sir.
range? The range will become your 1, 2, 5 or
5,
4,
4,
5,
7.
7. Right? Here 3 is not mentioned, 6 is not mentioned. So what is exactly range? Range is the set of all outputs. This is the outputs, and we have taking the sets of these outputs. Got my point?
Yes, sir.
So
Yes,
range
Got
is
it.
basically a subset of
Yes,
codomain.
sir.
And what is range exactly? What are the value function are giving me as output? The collection of those values is known as range. Got it? What
Yeah,
are
sir.
the
Got it, sir.
values
Yeah, it is
function
clear.
is giving me as an output? Collection of those values is known as range.
Range.
Sir, can we say codomain is a subset of domain? No, we can't. Okay, we cannot say like that. In this example,
Domain and domain are two different things, right, sir?
yeah, these both are different. Just think about this potato example, no? Potato chips example. Does the chips are subset of this potato?
Potato, no.
No, chips are different thing. Potato are different thing. You can you can eat chips directly. You cannot eat potato directly. Right,
Yeah.
Asos?
Yes, sir.
right?
Clear.
Both are different. Hello, sir. Are you ignoring the Prime Minister of India's message? What is the message, Narendra? Who is Prime Minister of India? As Prime Minister of India, it is my duty to guide you. What duty? What kind of guidance? Hey, how can you dare to report Prime Minister of India? What thing is going on in this group?
Sir, I think he is just spamming.
Yes,
Hey,
sir.
please don't do this kind of thing. Okay, it just
Sir, ignore it.
okay, it will interrupt our classes. We are here for studying, okay, not for doing any kind of politics. Okay, we are a student.
It's
So
not a
behave like
politics.
this. Okay, we will discuss this later. Don't worry. In the another class where we will talk about anyone's politician and we will discuss that kind of thing. But this is a mathematics class. Don't behave like thing. No, no, Garv, we cannot say like that. Okay, it's okay, Naren. Please, from anyone's class, please try to understand the topic. Don't move outside the topic. I am taking those example from your real life only because the concept will be helpful for you. It will be easy for you to understand. Okay, that is my duty. No, otherwise this thing you can learn from any book. There are so many nice books. If you want, I will recommend some. I am here only for doing this thing more easier for you.
Sir,
Uh,
sir, excuse me, sir, one doubt, sir.
yes.
Sir, always there is a one-to-one, sir. For one element, there will be one element as an output.
Yeah.
There won't be, that is one to many, it won't be possible in functions. Is it right, sir?
No.
Sorry, I didn't hear you. I was reading that message that is given in chat box. Okay, Naren, the thing is, I like teaching. That is why I am teaching here. Otherwise, there is no such thing that I have to do.
Sir, ignore
Okay,
it,
let it go.
Sir,
Narendra.
just please ignore, sir.
Okay,
Yes,
okay,
sir. Please ignore it.
okay. Okay, so what was you are asking?
Sir, there is only one-to-one mapping, sir. There won't be any
Ye-
one-to-many mapping, sir.
Yeah,
Yes.
there could be any kind of map. Here I was explaining for sets only. Sorry,
Okay.
I was explaining for function, general function. What is it? Here
Okay.
may be
So,
possibility
but
that
only two types of mapping is there, one-to-one and many-to-one.
One-to-one and many-to-one.
Yes.
Okay,
One to
ma'am.
many is not possible in
Possible in
function.
functions. Okay,
Yes, if
that's
it
the
is one
question.
to many,
just
then it is not a function itself. It's a relation.
Okay, okay.
yeah, that
Okay,
is I have
clear.
already wrote here now. That is
Clear,
I have
clear.
wrote here. If I will give the input, I will
Okay.
get the output, and that output will be
It will
unique.
be
There is
unique.
no such thing. Say one out. Yeah,
Okay.
unique. It
Okay.
will be
One
unique.
to one and many to one. Oh, okay.
Yeah.
Okay,
See,
ma'am. So thank you.
don't think that much about. Don't think that much about this kind of terminology. Don't worry. I will let you know what kind of this many to one, what kind of this one to many. Okay. This just a terminology.
Okay, sir.
Okay.
Okay. Okay.
Just
Clear,
a
sir.
terminology.
Clear.
Up to this here, what is domain, what is codomain, and what is range?
Yes, sir. Clear.
Clear?
Clear. Very clear.
Please
Crystal
don't
clear.
make so much noise in the chat box. Please, I am requesting you. Otherwise, I have to block you. Please. Hey, Prasad, don't write like that. Okay? Please, I am requesting you. Please don't do that kind of thing. Okay, so a domain is done, codomain is done, and range is done. So what is function basically? Okay, so up to this we have discussed about definition of function. So what is function? Function is nothing but it's kind of magic box which is taking some output and giving me some taking some input and giving me some output, some values as output, some product as output, right? One
Yes,
more
sir.
thing is there. We can also say if we have a set A and set B, and suppose here is function is defined, just like in this example. In this example, what thing is happened here? 1 is somehow related with this A. 2 is somehow related with this 2. 3 is somehow related with this 5. Though the relation is defining like that, but this is kind of relation. Are you able to see? This
Yes,
is
sir.
relating to different sets, right?
Yes, sir.
So can we say a definition like that? A function is nothing but it's a special kind of relation.
Yes,
And
sir.
what is the speciality on that relation? The relation should follow that these two rules.
Unique image.
Yes, sir.
You are getting why what I want to say. I just want to say function is nothing but it's a special kind of relation. Okay, let me write. Okay, the function is what? Function is just a
Special kind of relation.
special kind of relation. Okay, so what is the speciality is there? What is the
That
speciality is
every
there?
inputs in domain is mapped to one unique output.
Exactly. So first thing is there. The first thing is
Every inputs in domain is mapped to a unique output in codomain.
exactly. The first thing is every input, or you may say every element, okay, element of set A. If we will talk about this set A and B, set A has an image.
Yes, sir.
What do you mean by this image?
Image
This
is
one is known as image of this one.
image.
This 2 is
Yes.
known as this image of this 2. This 5 is
Codomain.
known as image of 3. This 4 is known as image of this 4. This 7 is known as image of this 5, according to this function. Okay.
Yes, sir.
Okay.
So
So every
how these
element of,
functions are working?
sorry,
F of 3, F of 2 is equal to 5.
That just
see,
said
this is
together.
just an representation. This is just an representation. What does this representation is so? The representation is so this box is taking input as an 2 and giving me this F is nothing but this is a box. This is taking 2 as an input and giving me 2 as an output. Here, this function is at the same time this function is taking 3 as an input and giving me 5 as an output. See, you can see the symbol as well, right? F is a function operating in 3, giving me the value 5. See how simple it is. F is a function operating on 5, giving me the value 7.
Yes, sir.
Yeah, and those output set is range, right?
Yeah. Collection of outputs is range. The output set is codomain. Output set, it means where the outputs are going, where the outputs are going. Okay, there may be some sets where outputs are going. In just like this chips making example, there is a pod, there will be some pod where chips are collecting, right?
Yeah.
Sir,
Yes.
so where we have written that function of 3 is equal to 5, is there any pattern or just we have taken randomly the number 5?
Here we have taken randomly. There will be some function we defined like this, no? I don't know about that. Right now, I don't know about that. I am expressing explicitly, okay, explicitly, but I don't know. Right now, I don't know about this, but there will be some function which defined like this. I don't know the proper structure of that function, just like fx is equals to x square. I don't know that kind of structure, but there will be some structure which is following that kind of thing. There will be, no?
Okay.
Right now, I don't know. It's just like distance between Delhi and Bombay. Right now, I don't know, but there will be some distance, no?
Yes.
That's it. Okay. So first thing is every element. Yes, yes.
Mhm. So can the function form without codomain? Like it is giving outputs.
See,
Like input
sometimes your
system.
codomain, sometimes I'm saying sometimes your codomain will become your range. Okay, don't worry. Codomain is nothing but codomain is nothing from where the outputs are coming, from where the outputs are going, yeah, or for where the outputs are coming. That set will become your codomain. You're getting my point? Suppose your function is defined from A to B. From which set your function is defined is known as domain. From where this function is giving me output is known as codomain. And what are the output this function is giving? That collection of outputs is known as what? Range. Simple. From where function is taking values? Domain set. From where function is giving me values? Codomain set. What are the values function is giving? Collection of those values known as range set. Got it?
Yes, sir.
Yes, sir.
Yes, sir. Got it.
Okay. Now, here every
Okay.
element of set A has an image, and that image should be
Unique.
unique. Because I cannot get some extra potato. If potato can make only 5 chips, it will make only 5 chips. It will not give 6 chips. Okay.
Yes, sir.
Until and unless the machine will not broken or the machine will not be
Defective.
yeah, defective. Okay. So you understood the concept of function?
Yes, sir.
Now we will move towards one function and on to function. What is injectivity, subjectivity? Just give me 2 minutes. I will drink some water and just give me 2 minutes. Okay. Okay. So understood up to this functions definitions, domain, codomain, and range.
Yes, sir.
Okay. Let's take an example.
Yes, sir.
Let's take an example. Suppose your set, suppose your function is defined from set of natural number to what set of real number. Okay. And what kind of set, what kind of function is it is? This function is taking value as x and giving me value as x square. Okay. What does it mean? It means that suppose if your input is 2, it will take input as 2 and multiply 2 as multiply n times, and it will square this 2. What you will get?
4.
Don't worry. I will let you know what is real function. Okay. I have just explained the definition of function. Thanks for reminding me real functions. Okay, so Cassis real function is nothing but if your range, sorry, if your codomain set is set of real number, or you are getting values as real number, you will say that function is real function. That's it. Nothing is. No rocket
Yes,
science is
sir.
there. If set is
Yes,
defined
sir.
from, if f is defined from some set, a subset of real number to a real number, then you will say that function is real functions.
Sir, is real valued function and real functions are equal? Are
Yes.
same?
Yes. Real valued
Okay.
functions, it means domain can be anything. I don't know. I don't care what is. But the whatever outputs I am receiving, that output should be real. That is real valued function. Real function, it means that the function should be defined from a subset of real number to a subset of real number. Or you can say f has to be defined A to B. If this kind of thing is defined, then A and B both has to be subset of R. Okay, it means that the function is taking only real values, giving me the real values. But the real valued function, in the case of real valued function, it can take any value. Just give me output as a real value. We will say, yeah, this is a real valued function. Just like this example. Suppose I have collection of ABC here, and here 1, 2, 3, 4, 5. So A is connected with 1, B is connected with 2, C is connected with 3. F of A is 1, F of B is 2, F of C is 3. In this case, this function is a real function. Okay, it is real valued function, because it is taking some values. I don't know from which set it is taking, but it is always giving me an output as a real value. So it is known as real valued function. For real functions case, this input should be a real number. Okay, it means that this set A is subset of R, and this set B is also subset of R. Understood?
Yes, sir.
It's easy.
Yes, sir.
Nothing,
Thank
no
you.
rocket science is there. For your case, there will be only real function or real valued function. Okay, it's just a terminology. Don't worry. Okay, so in this case, suppose you have this fx is equals to x square kind of thing. So now, what will be your domain? Can someone please say domain of this f?
1,
N,
2,
right?
3, 4, 5.
Natural numbers.
All the
Natural
natural
numbers.
numbers.
Natural number. What will be your codomain here?
Square of
Real
natural
Real
numbers.
number. All real
That
number.
All real numbers.
okay.
Natural.
What will be your range?
Square of the
of
All
numbers.
real number.
Square
Of
of
the number 1, 4,
4,
9,
9,
then
16,
16,
25,
25, 49, then
64,
49, 64,
64.
and in 81, 9 9 is 81,
So
then
here
100,
range can also be
121.
defined as natural numbers, right?
The
It's
range
not,
is
yeah,
be 0.
it's a subset of natural number. Okay.
Yes, sir.
Okay, not a set of natural number. See,
But
here,
take the square of a natural number.
yeah, here R is different. Sorry, domain is different, codomain. Okay, codomain is different and range is different. So you can see there is no
Yeah.
such relation between domain, codomain, and range. But what I have seen here, this range is always a subset of this
Subset of
codomain.
codomain.
Okay, because this
Sir,
value is coming from this codomain only. Yes.
the range will include 0 also, no?
Yes.
Yes, sir.
Yeah, for
Yeah.
you, natural number is 0. Okay, thank you.
Yeah.
0 is also included in a natural number. Actually, for me, 0 is not included. 0 is not considered as natural number, but for BS degree, 0 is considered as natural number. The reason behind it, because most of the language is start counting from 0, right? Especially Python. Python start
Okay.
counting from 0. It is not start counting from 1.
Yeah.
Yes, Devraj, you want to say something? Devraj? Okay. So here you got my point. Range is always a subset of codomain. Domain set is different. Codomain set is different. Range is a subset of codomain. Okay. Sometimes those two set will be equal. Okay. Just like if I will say if this set, this B will become your range set only, then in this case range and codomain will be equal. Okay. Okay. Now let's make some constraint into this function. Okay, so this is what injective function that I am going to explain. Before that, if I am missing something, let me see. Injective. Okay, codomain. After codomain, injectivity is there. Does sir has completed that concept of prime number kind of thing or irrational kind of thing?
Actually, yes. Sir started in previous open sessions. Sir started it from sets because it was understood that numbers, real numbers, and prime numbers, rational numbers are just
Yeah,
basic
that
concepts,
is.
and we know that.
Yeah, that is very basic. Because the after function, I have seen the slides and I have seen the lecture videos. In that videos, after the function, they have mentioned some prime numbers, irrational kind
Yeah,
of thing.
that is additional. We need not to see that. That's not necessary for us.
Okay,
It is
so
written there.
okay, so I can exclude that part. Can I?
Yes, sir. Yes, sir.
Yes,
Or
sir.
I have to
You may.
mention those part as well.
No, sir. You
I
just
will take the countability part. Don't worry. I will take that countability part. Sir has explained the countability part.
countability. Sorry.
There is something, right?
No, sir.
Countable
No,
set.
sir. So, sir has actually attended the does
Did
not
you
attend
seen
the.
the lectures video? In the
Yes,
maybe
sir.
last
Yes,
lecture,
sir.
there is some countable thing.
Yes, sir. Yes, sir.
Yes,
It's
sir, it's
there.
there.
Okay, sir did not explain those things, right?
Sir, it was explained in the recorded lecture.
Yeah, degree of infinity, that kind of thing.
Yes, sir.
These are the additional things. No, we need not to study that.
Yeah, but just sake of thing. There may be possibility that I will ask you some question on that,
Okay,
or
sir.
sir will ask you some question on that. There may be possibility.
Okay.
Or there will be some question in graded assignment. There may be possibility. I don't know. I didn't see in the graded assignment as well.
No, sir. It's
But there
clearly
may be.
mentioned there
not
that
yet.
it's not in qualifiers or quiz one content. It's mentioned there.
But
We
what
need.
about NSEM?
Yeah, it's not included in NSEM as well.
Okay. So if we will get some time, we will have some time, we will discuss that countability part. Otherwise, we
Yes,
will
sir.
not. Okay.
Sure, sir.
That is just a additional information. Okay. Thank you for telling me this thing, because I was not aware about that. That is
Yes,
not a
sir.
part of your syllabus. I thought that is also a part of your syllabus. Okay.
Oh, sir.
So what is injective function basically? Just forget about this injectivity word, or you some people will say one-to-one function. See, name is saying so many things here. So in as previous case, we have two sets A and B. Okay. Function is defined. A, B, C, D, E. Here, 1, 2, 3, 4, 5, 6. Okay. How this function is defined? Here, f of A is 1. F of B is suppose 3. F of C is suppose again 1. F of D is 4. F of E is again 4. Okay. So what is going on here? Here, A is also taking 1. C is also taking 1. It means that the two different inputs, say A and C, giving me the same output 1.
Yeah.
Right? In this, similarly here, two different inputs, say D and E, giving me the same output 4.
Yes.
Yeah.
Right? So this kind of function is known as many-one function. Why we will say many-one function? Because there are many outputs.
Inputs.
Many outputs and inputs. Okay. Sometimes I want to say inputs, but
Yeah, yes, I totally understand.
Yeah, it happens.
so okay. The tongue twist kind of thing.
Yes, sir.
So the thing is, this function, what this function is doing, it is taking inputs. So there are two different inputs for one output, right? So what is one function? It means that the function is taking many items as an input, but it giving only unique item. Or you can say, what you can say? You can say it is. Did you seen that? What I will say? Did you say that sugarcane से juice निकालने वाली machine kind of thing?
Yes, sir.
Did you see that
Yes,
juice
sir.
making machine?
Yes, sir.
So whatever item will you throw inside that machine, it will give you just juice only, right?
Yes, sir.
Yes, sir.
That kind of machine is
Yes,
also
sir.
a many one function.
Yeah, yes, sir. We can say that.
Yes, sir.
Yes,
You
sir.
can say like that, right?
Yes.
Yes. So that is kind of thing is there. What do you mean by this many one?
Sir,
Many
excuse
one?
me, sir. Sir,
Or
there
you can
is
say
a
many.
student named Narendra Modi. He's messaging me and he's just, sir, just very distractive in this session. And he just did some personal message to me asking me if I am Brahmin. Why am I chattering so much? Stop it, he's
Just a
facing
minute.
disturbance.
Okay, just a minute. I will stop the thing. Let me see.
Sir, I have a question.
Yes, yes.
Sir, in the lectures, we saw that the teacher were referring that we are including zero in natural numbers. And if there is some function like given by y is equal to 3x, y is equal to fx
Okay.
is equal to 3x, then if
Okay.
that domain is natural number, then we are supposed to include zero.
Just a minute. Let me see. Narayan, please don't do that kind of thing. This is your last warning, okay?
So that
If you will do
message
this
came
kind of
personally to
thing,
you. He just
if you
messaged me in
will,
person.
yeah, if you will do this kind of thing again and again, you will blocked by authorities, okay?
Sir, I think he has came from the different name. Just remove him because he is disturbing far from the time.
Yes, sir.
Everyone deserves a second chance. That is why I am saying I
So
don't
he
want to.
Sir, is there any specific team we can complain with disciplinary issues?
You can directly
We can
ask
support
to
them the complaint
support team only
to the
for any
management.
communication. For anything, you have support team. Okay,
Support
they will
team,
take
sir,
care of.
for
Yeah,
every issue, how can we address them only?
see,
They
the
handle
support team is
thousands
only
of
for
issues.
you. The support team is only for you, guys. Whatever issue you are facing, you can tell them. Okay, whatever disciplinary kind of thing is happening there, you can directly say them. Okay. Naren, this is your last warning. If you will do this kind of thing again and again, you will not be able to attend any kind of live session. Okay, don't interrupt the class. If you don't want to attend, you just leave the class. I know you know each and everything. That's acceptable. But if you are doing this kind of thing, that is not acceptable in any kind of thing. Even Narendra Modi will not going to be accept this kind of manners. Okay, so please don't do. Just behave like a man. Okay, so what is many to one function? Basically, this kind of function. Okay, so in this function, what this function is taking? This function is taking different kind of values, but giving me same output. I am not saying for each and everything. Just like juice making machine, suppose this is your machine. I am again saying I am very bad in drawing. If you will put oranges, he will give me orange juice. Okay. If you will put mango inside it, it will give me mango juice. Both are different, right? Both are different. But here, if you will, even if you are putting different oranges, you are getting orange juice only.
Yes, sir.
So suppose you have a collection A of sets of fruits. Okay, sets of fruits, capital F I can write. Sets of fruits. Here apples are there, bananas are there, or what you will say, what are the fruits are there? Grapes are there, oranges are there, so many fruits are there. And this is your potato making machine. How will I make it? This is your potato, this is your switch. Okay, mixy kind of thing that you can see, mixer machine. So whatever thing, suppose you are putting here apples, different apples you are putting, but you are getting a juice only, right? Apple juice, tasty apple juice.
Yes, sir.
Now, after that, you are putting bananas here. You are getting banana juice, grapes here, you are getting grape juice. So what is this kind of thing? This is behaving like a many one function. What kind of thing it is doing? It is taking a different inputs and giving me same kind of output, right? Similarly, in this case, if you have a set R, suppose this set F is defined from R to R. And what kind of set it is, what kind of function it is? It is fx is equals to x square. So in this function, what is happening here? This function is taking some value x from this R and giving me output as an x square. So in this case, if I will take value -1 and I will take value 1. So what will be your f of -1? It will be
1.
Sir, your voice is not audible.
Sir, you are not audible.
Sir, you are not audible, sir.
Okay, you went to mute.
Yes, actually, I got a call. Okay. Sorry for disturbing. Okay, so your function is what? Fx is equals to x square. So in this case, if you are -1 behave like an input, what you will get? -1 whole square. In this case, what you will get? 1. Right? Again, if you will put input as 1, what you will get? 1. See, though you are giving the two different values as an input, you are getting same values, right? So
Yes,
this
sir.
kind of function is known as many one function, many to one function or many one function. So in this name, you can easily see many, it means that giving many values, one, it means that mapping to only one value. Getting my point?
Sir, I have one
Got
doubt, sir.
it.
Sorry. Yes.
Sir, can you please discuss some more complex word problems on each type of functions?
Okay. Did you see that absolute
Yes,
value
sir.
function?
Sir, there is activity question 9 in 5. Can you solve this?
Yes. You just take a screenshot and paste here. I will take that. Okay.
Okay, sir.
Okay. Okay. So in this case, if you will take -2 as an input, what you will get out as an output? You will get 2. If you take +2, you will get 2. This is also an example of many one function, right?
Yes, sir.
Now, so apart from that, this is one thing. But there are some function for that. If you will give one input, you will get one output. For different input, you will get different output. For another different input, you will get different output, right? There are maybe some function, there are maybe some different magic box.
Yes, sir.
Just like, suppose your magic box is doing multiply by 2, any number, fx is equals to 2x. So for each number, for each different number x, you will always get different value, right? Suppose you are giving me 1, what you will get? 2. You are giving me 2, what you will get? 4. Both are different. For any two distinct output, you will get distinct input, you will get distinct output, right? For any
Yes,
two
sir.
distinct number, you are getting two different number. So that kind of function is known as one-to-one function.
Increasing or always decreasing functions.
Okay, increasing, decreasing, we will discuss later. Okay, in the maybe after week 4, we will discuss about increasingness, decreasingness. Don't worry about it.
Sir, I have one issue.
What is
Hello.
the issue? Yes, yes. What is the
Sir,
issue? It is
in the lectures, the professor said that we are taking zero in the set of natural numbers, and if some relation is giving by like 3x fx barabar 3x, then we are taking and the domain is natural numbers, then we will take zero as a value or not. That's what I was asking.
They will take zero as a value. Now, if they are saying, yes, a natural number includes your zero, so it includes your zero. That's it. There may be possibility that they will forget that thing by some point. At some point, there will be possibility because we are human beings. We can forget the things. Okay. There will be some
Okay, so
things.
in the graded assignments and practice assignment, we are taking zero in natural numbers as well.
Yes, exactly. For you guys, zero is included in the set of natural numbers. Okay.
Okay. Thank you, sir.
For all the BS students, zero is included in the set of natural number. In general, zero is not the natural number. Actually, the thing is, this Python kind of thing is made by some US guys, right? Mostly, it is made by some USA guys or some European world. So they consider zero as a natural number. As of my knowledge, they consider zero as natural number. That is why this kind of thing happened. And since Python start counting from zero, that is why you have to start counting from zero. Otherwise, this will be very confusing kind of thing for you, right? That is why. Okay, so one-to-one function understood. So
Yes,
in this
sir.
function,
Yes.
what you will say, you will take one input. For one input, you have one different output, right? So in this case, what kind of thing happened? Suppose this is your A, this is your C. Formal definition I am not writing here because formal definition you already have in the slides or in the lectures videos. That is why I am not writing. Or maybe there is some book kind of thing is there. For math 2, it is there. I don't know about for math 1.
Yes, sir, it is in the supplementary section. Books.
Yeah. So what in this case, each element have unique element. That kind of thing is happen. So what is the formal definition for that? The formal definition of that is saying if x1 and x2 are not equal to each other and x1 and x2 coming from A, then fx1 will not be equal to fx2. This is the formal definition. Okay. Right. So this kind of function is known as many to one function. Okay.
I'll let you know
Now
what
again.
we will discuss in this session.
Can someone please mute yourself? Someone is playing the videos, I guess. I don't know who. Please mute. And Sumit, are you? Please mute yourself. Okay. Then on to function, or you will say surjective. Okay. So what is surjective function actually? Nothing but here I have discussed one case, right? I have told you now. Here there may be possibility that this range will be equal to this codomain. Right?
Yes, sir.
So in this
Yes,
case,
sir.
whenever the range set will equal to the codomain set, we will say this function will become your surjective function. So what thing is happening in this case? If the range equal to the codomain, then we will say, yes, this function is become a surjective function. Got it? Easy now?
Yes, sir.
Yes.
Very easy.
Easy peasy?
Sir. Yes,
Yes,
sir.
very easy.
So till now what we have discussed? We have discussed the definition of relation. We have discussed the definition of function. We have discussed surjective function, injective function, many-one function, domain, range, and codomain. Now let's discuss about the relation between
Sir, I have a one doubt.
Huh? relation and function. What doubt you have?
Sir, many one function say bijective function.
No, actually bijective thing I will discuss after this relation. Okay.
Okay, sir, done.
I don't want to make so much rush on the injectivity or surjectivity. That is why I skip that. Basically, bijectiveness is nothing but if a function f is injective plus surjective both simultaneous in one time, then we will say, yeah, this function will become your bijective function.
Okay,
That's it.
sir,
Nothing
done.
is there.
Got it.
Nothing. If function is 1 and onto both, we will say function is bijective. For
Okay,
example,
got
fx
it,
is equals
sir.
to this x. Or you will say not x square. What you will say 2x. That kind of function. That's it. Nothing is there.
Okay, sir, got it.
Let's discuss about relation and function. So function is what? Suppose you have two sets. I have already told you function is nothing but special kind of relation. It means that function, the set of function always become a subset of relation, right? Right. Now, why it will become, that I will let you know. I have told the definition, right? Function is always a relation special. Why it's a relation, that I am discussing right now. Suppose it has element A, B, C, and D. And it has element 1, 2, 3. Your f of A equals to 1. F of B equals to 2. F of C equals to 2. Okay. Hello, am I audible?
Yes,
sir.
Yes,
Yes, then please respond. Please respond. So what kind of thing is happening here? Here, your A is meeting with
1.
1.
Your B is meeting with
2.
2.
Your C is also meeting with
2.
2. So rather than writing this way, I can write by this way, right? It's just a representation, na? It's just a representation. Just like my name is Arpit Amrate. Arpit is just a representation for me. That word is representing me.
Yes,
right?
sir.
Yes.
Yes, sir.
Rather than writing this way, I can write this way.
Yes.
Yes, sir. Yes,
And
sir.
this is what? This is a relation now.
Yes, sir.
Yes, sir.
Yes.
So that is why we will say, yeah, function is a relation and special kind of relation. What is the specialty is there? Each value of input set always have an unique output.
Yes, sir.
Right?
Yes, sir.
Understood? What is the relation? Easy, no? Easy, no? What is the relation?
Very.
Very easy. Okay. Okay. Understood up to this? Now, what tells after that? Is there anything that I am missing right now in the function part? Please let me know if I am missing. Otherwise,
No.
I will take your doubts.
What will be not a function?
What will be not a function? Okay, that kind of thing is not a function. Let's see. Suppose you have set of all real number. Okay, 0, 1, 2, 3. Here between 0 and 1, you just say here there are some number -1, -2, -3. Now, I am defining f of x is equals to root x. Here also real number are here. 1, 2, 0, that kind of thing. Just this number has image. This number has image because root 1 is defined, right? This is 1 only. Root 2 is somehow 1.414 kind of thing. I don't know the exact value. No one knows the exact value. Root 1 is 1, root 2 is 1. This kind of thing is defined. What about this root -1?
It's a complex number, sir.
It's a complex number.
But complex number is not a part of this real number, right? If I am defining a function from R to R, this is not the part of this real number set. This is not the part of the output set. It's just like chips making machine. If I am taking input function as an stone. Okay, there are some potato, there are some stone. What will happen? The machine will broke.
Yes, sir.
Yes, sir.
Getting my point? In this case,
Yes, sir.
-1 was not the part of domain, right? I am forcefully include that -1. Now, in this machine, if I will include the -1, will I get chips?
No, sir.
No, sir.
In this case, I will get some ulta seeder thing, right?
Yes, sir.
Yes, sir.
So that's the thing. So in this case, will this function work on this domain or on this set?
No, sir.
No, sir.
No,
No,
sir.
sir.
Will this be
No,
a
sir.
function for this? No, right? Because I cannot use this -1, -2, -3 as an input. So this is not a function. For this set of real number. Get it?
Got it,
Yes,
sir.
sir.
Excuse me,
One
sir.
way. Yes.
Sir, is it like
Yes.
every linear function is an injective function?
Yeah. Every linear function is an injective function. Okay.
Answer quadratic.
Not every linear function. Not sorry, quadratic is not a linear function. Why? Because suppose f of x is equals to x square is your function, -1, what will be the output? 1. 1, what will be the output? 1. Manual
Yeah.
function, not injective.
Yeah,
But
okay, sir.
linear, sir, linear will be injective always.
This kind of function will be injective. A is not
Al
equal to C.
Always.
This is a linear function, right?
Yeah.
This always be a injective function.
Okay.
Sir, I have a doubt.
Yes, Chirag, that will be covered after week 4. Don't worry. Exponential function. No need to discuss here because there will be some. See, we have to make some kind of base now. Then only we will explain further things. We cannot directly take that kind of thing. That is why. That is why I am taking here some small example only. That is why I am taking some chips making machine kind of example. Otherwise, I can take directly some well-defined function. Yeah, it's almost out. It's already done. Yes, someone was asking something. Yeah, you can leave if so you want, you can leave.
Sir, I have a doubt.
Yes.
Sir, is there any condition for onto function too, just like injective functions have a condition fx1 is equals to fx2?
See, yeah, the condition is nothing but it's a basic definition. If f is defined from A to B, everyone knows A is domain, B is codomain. Then f is said to be onto if and only if for all, this sign is known as for all. It means that we are taking all the value from B for all values coming from this V. I hope you are aware of this sign, or you can say
Yes, sir,
for
I'm aware. Yes, sir, I'm
for
aware.
every Y in B, there exists. This is exist.
There exist.
There exists an X in A such that f of x is equals to y. What does it mean? It means that for each value in B, there is a value in A. For that, somehow this value is related by the value of A with the help of this function. Okay,
Yes, sir, I
not
have
time
got it.
pass,
Thank you,
Chirag.
sir.
Yeah.
Okay. Sir, I just joined. I just want to know what the session was all about. Not the time pass. It was the about the session.
Guys,
Okay.
activity 9 question in 3.
Yeah. You have sent, no?
Yes, sir.
Sir,
Yes.
sir, you mentioned that ax plus b will be injective. So if we
Mhm.
put under root,
A is
square
not
root,
equal to 0. Okay. Sorry.
yes, sir. Sir, so if we will put
What?
under root like square root of ax plus b, it will be always injective then also.
Square root of
Ax plus
ax plus b.
plus
This
under root
is
under yes, sir, full under root b also is yes, sir.
okay. This kind of okay. So firstly, what will be the domain? Ax plus
Greater
b
than
should be greater than or equal to 0, right?
0.
yes,
Yes, sir.
Then x should be greater than or equal to minus b by a,
Yeah.
yes, sir.
Okay.
right? What will
Yes.
be your graph? Your graph, suppose this is your minus b by a. So your graph will be look like this only. This will become your
Okay,
function,
sir.
injective function, increasing graph.
Okay, sir.
So it will be injective always.
Yeah, cannot take this value. It depends what are the domain you are defining. Sometimes it will not be a function as well.
Okay,
There
sir.
may be
But
possibility.
so if something is given under root, then it is understandable that it will be always positive, more than equal to 0. So
No,
Yeah,
it can be
exactly.
equal to 0, no?
yeah,
It can
more
be
than
equal to
equal
0.
to.
That is why I am
Yeah,
taking here.
yeah. Yes, sir.
Sir, actually, I didn't
Okay.
understand that graph thing because I'm from non-maths background, but I got that
Okay.
under root thing that it will be injective. Okay.
Yeah, sir. Same.
Okay,
I
don't
also
no,
not understand.
not to worry. Not to worry. This graph thing will become okay. Whenever we will discuss about polynomial and quadratic thing, this graph will come into picture. Nothing is happening here. I just see if you want to see the graph, there is no such thing. For math one, there are some for your course I am talking about. Basically, you will work with the data science, right? So this how the graph is making it is not so necessary for you. It is just a conceptual thing. So I am suggesting you one website known as GeoGebra. Okay, just go through it and give some functions into it. He will give you the graph. Okay, whatever you required, because you will write some codes for making graphs kind of thing. So that is not so important. Sir, can you
Sir,
explain Rolle's
I have a
theorem?
general
How
doubt.
will I explain Chiran? Rolle's theorem is a part of differentiability and continuity. And you are just learning the functions part only.
So this
Practice
Sir, I
session,
person.
have a jo-
or you can go by Desmos, whatever you want. I think you have heard about this.
Sir, I have a general
GeoGebra and
doubt.
Desmos, whatever you want. Okay, if you want to leave, you can leave. The session is over already.
So
Someone
excuse me,
was
sir.
asking me that.
Sir, you had
Sir,
not
how
discussed
long
function on
this
line,
class?
sir.
Yeah, function of line. Yeah, I will discuss. Don't.
So before the
Sir,
That
session end, I have something to discuss with you, sir, and it's important.
yes,
Yeah, before
sir,
the
yes, yes,
session end,
yes.
if when everyone leaves,
Mm.
sir.
Please take the one
Yes, yes,
question
yes,
from
yes.
here.
sir,
Just a minute. Can
I
I
have a
take the
doubt.
question number this
Yes, sir.
one by one, please? One by one. Let me explain this.
Sir, I have a
Whatever the
doubt.
question. What doubt?
How
Just a
long this
minute. Just
class?
once the doubts will over, I will close the class. That's it.
Okay, I will leave the class because I have
Yeah,
no
you
doubt.
can. Okay, you can leave the class if you have no doubt. No issue. What is the function fx is equals to?
Can I ask the
Just
question of practice assignment here, sir?
let let me finish. Let me finish. See, don't ask any questions from graded assignment. Okay,
No, sir, I am talking about practice assignment, sir.
you can ask practice assignment question. I will give you the hint. I am not going to solve the question because it is the practice assignment is only for practice. Okay. So what is the question? Fx is equals to x plus 12. Okay. So what is it? If the domain is this defined by the function this, then what will be the domain? Okay. This is x plus 12 and 4x minus what? 8. Whose doubt is this? Saket, are you there?
Yes, sir.
Saket,
Yes, sir.
are you
Yes, sir.
there?
Yes, sir.
Okay, so Saket, what is the domain? What output? What kind of input this function can take? See, in the PYQ form, this Q cannot be equal to 0, right?
Yes, sir.
Because the number should be real, now. It has already
Yes.
say this fx can be real number only. So in this case, Q cannot be 0. So
Yes,
for
sir.
this case, if this will become 0, in that case, this function will not be defined.
Yes, sir.
Because this is a real number, and if this denominator will become 0, it cannot be no longer the real number, right? So for
Yes, sir.
this case, what the value of x will include the 0 kind of thing in the denominator. If 4x minus 8 will become 0, this function will not be defined.
Yes.
For any value after otherwise for any value, this function does not have any issue, right?
Yes, sir.
So what is the value actually? X is equals to 2. So what will be your domain? Your domain is R excluded by 2. It means that apart from this
Yes.
2, everything is there in this R.
Only
What this will
x
be.
x can't take the value 2.
Yeah, exactly. Otherwise, this denominator part will become 0.
Yes, sir. Yes, sir. Then the function is not defined.
Yes.
Should be represented as a set, right, sir?
Yes. Okay, so question number 5. Someone had asked this question. Which of the following function is the injective? Okay.
Yes, sir.
Sorry.
So I was asking the last term 5x plus 4 and 2x minus 3 and divided by 2. Why this function is not injective?
It is considering what is the domain. Domain is R. It's not injective because it is considering the set x square kind of thing, you know. Like what will be your function? 5x minus 4, 2x minus 3. Okay. 5x minus 4, 2x minus 3 divided by what?
2.
Okay. I am asking to you, if x will become your 4 by 5, what you will get? 4 by 5,
No.
0? If it will become your 4 by 5, you will get here 5 into 4 by 5 minus 4. This will become your 4 minus 4, which will become 0. And if you are multiplying 0 with any constant, what you will get? You will get 0 only. Right?
So, yes, sir.
So this will become your 0. Now, what will be the value of 3 by 2? 0 only. Here, just put 3 by 2, 2 to cancel out. 3 minus 3 will become your 0. See, two different value is giving me the two same value, not the injective function.
Oh, okay, sir. Thank you so much.
Easy. Yes.
Sir, to
Okay.
summarize, injective is 1 to 1. Then surjective is codomain equal to range.
Yes.
Okay, sir.
So one quick question. When we have a quadratic equation like an x square, that becomes a parabola, and that is why we say that it is not injective. But if the domain is only positive real natural numbers, then it becomes half the parabola, and then it should become injective, right?
Hello, am I audible?
Yes,
Yes, sir.
sir.
Now
Yes,
you
sir.
are.
Yes, sir.
Okay. Actually, my mic. Oh, sorry. Actually, my Wi-Fi was off somehow. I don't know how. Sometimes it happens. Okay, so what is linear function? It is nothing but a function of a line is known as linear function. Or you can say fx is equals to ax plus b kind of function is known as linear function where a is not equal to 0. That's the definition. What does it means? It means that this is the function of line. Now, if we will discuss about the property of this function, see, this function is injective. Why injective? Suppose x1 and x2 both are two distinct number. Okay. So what I have to show? I have to show fx1 not equal to fx2. Then we will say, yeah, this is an injective function, right? I am going to the formal things. Just if you want to listen, you can listen. Just cooperate me. If this function is injective, so for any x1 and x2 not equal to each other, x1 not equal to x2, you will get that kind of thing, fx1 not equal to fx2. If it is injective, I am saying. Hello, am I audible?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Suppose this is not happen. Suppose fx1 equal to fx2. Suppose this is happening. What will happen? Ax1 plus b equal to ax2 plus b, right? According to this function, b will be cancel out. What you will get? Ax1 equals to ax2.
Sir.
X1 equal to x2. Yes. But what was my initial assumption? My initial assumption was x1 not equal to x2. It means that this assumption is wrong. And then fx1 not equal to fx2 is right. So it means that f is injective. What? What? Someone was asking something.
No, sir, I got it. Sir.
Hello. Got it? This assumption was wrong because I am getting this, but I have assumed this x1 not equal to x2, which is incorrect. That is it means fx1 not equal to x2. So this is injective function. Is the function is surjective? Let's see. If surjective, it means that for any y belongs to R, there may be some x. Okay. So what is this x? Let's talk about this. Suppose your f(x) is equals to y. It means that ax plus b is equals to y. It means that ax is equals to y minus b. It means that x is equals to y minus b by a. And why it is defined? We already considered that a is not equal to 0. That is why it is defined. So for any y, for any given y, we have the value of x for which you are getting output as y. Just put input as y minus b by a. What you will get? You will get a times y minus b by a plus b. This will be cancel out. Y minus b plus b, which is equal to y. Right? So this is surjective as well. So this function will become bijective because it's a surjective and surjective and injective both. Right?
Yes, sir.
Yes, sir.
Is there anything else that you want to ask? Or I can close the session.
No, sir, I have something to discuss with you before the
Sir, I
session.
Yeah, you
have
just.
a doubt.
Bijective and
Yes, please. Yes.
Sir,
You just
relation.
ask.
Sir, please, relation, sir, reflexive transitive equivalence.
Okay, let's see relation. Binary relation, basically.
Sir, in the
Is there anything
meanwhile,
apart from?
I have a doubt, sir, in relations only.
Okay, let me I will explain the relation. Just give me 5 minutes. Let me drink water.
But my doubt is that is every binary relation possibly a symmetric relation?
Not at all. Both are totally different. Every
Different.
symmetric relation is a binary relation, but not
Over river.
No, reverse part is not. Just a minute, I have to take some water from it. Just 2 minutes. Okay. So those guys who are sending the questions in the chat box, I am suggesting you please make a WhatsApp group and discuss the question there itself. Okay. After that, if you have some doubt, then you just ask to any instructor. Otherwise, very difficult for us to take each and everyone's doubt, right? It's very difficult. There are so many students, like in the 100 student class, it's very difficult. But there are so many. So difficult. I cannot solve each and everyone. I cannot resolve each and everyone's doubt. So for that, I am suggesting you that someone please take the initiative and make a WhatsApp group. You can paste the link here itself so that you guys can join that
So
group and you
there's
can
a
discuss.
session
Okay.
also to solve the doubts.
Sorry.
There's TA
Discourse is
session
there.
also.
Discourse.
TA session. Yeah, Discord.
TA session is there, but for discourse is also there. For TAs also, see some of the students there is a possibility they are not so aware about discourse kind of thing. They are not like some of the very habitual to operating the WhatsApp. WhatsApp is very easy to accessible for each and every person, right? So you can easily ask. That kind of thing is only for your official work. You cannot do gossips into that kind of thing. And in that WhatsApp group, this is since unofficial group, so you can discuss or you can talk other than apart from that itself. Right? So that is why I am saying between the studies, it's better if there will be some fun activity kind of thing. Otherwise, that kind of thing will become boring. Okay, so binary relation, I have already told you what is kind of binary relation. If R is a subset of A cross A, we will say, yeah, this relation is a binary relation. Up to this, you have clear, I hope, right? Right? Please let me know.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So there are some types of binary relation. Types of binary relation. First is known as identity relation. Did you heard this word? Okay. Did you heard this word identity
Yes, sir.
relation? No.
Yes,
Okay.
sir.
So what is identity relation basically?
Yes.
If for each A belongs to this capital A, for each A belongs to this A belongs to this R. Or you can say not this exactly. Sorry, this is an reflexive relation. R is said to be identity relation if R is equals to AA for all A belongs to. It means that if your set A is what? 1, 2, 3, 4. Okay, so this R will contain only this kind of element. 1, 1, 2, 2, 3, 3. Four, four. Only. Getting my point? There is in this set, if this is identity, there is no such kind of element like 2, 3, 3, 4. There is no such kind of element. Okay. In this set, there are only 1, 1, 2, 2, 3, 3, 4, 4 kind of element. And for element of this A, what does it mean? It means that there will be a kind of element for all A belongs to R. Getting my point? It means that there will be no such element will left for this. Getting for each A, there will be a kind of element inside it. Right? Or only that kind of elements are inside. See, for all A belongs to. There will be no such 2, 3, 3, 4 kind of thing is there. That relation is known as an identity relation. Okay?
What if there is
now
no
reflexive?
No, what if there is no one pair? For example, 1, 1, 2, 2, 3, 3 is there, 4, 4 is not there. Will that be still an
So this will not become this will not become your identity relation. Here I am saying for all A. For every A belongs to this. Sorry, not this R, this A. For every belongs to this A.
Sure, thank you.
If 1, 1 is not there, or suppose one of the pair is not there, we will say this is not an identity relation. Got it?
Yeah, thank you.
So this relation should be unique always. Unique means this relation always contains this kind of element for a given set A. For given set A, in this identity relation is always same. You can see no other element can go inside other than that.
So please
If
repeat
someone
once.
is going, it has to be satisfied this kind of thing. No lesser, no larger. Yes.
Please repeat once, sir.
I am saying a binary relation R is said to be identity relation if R is contain only this kind of element, a kind of element, and for all A belongs to A. Okay. We cannot left anyone here.
2, 3, 3, 4, all are related.
That kind of they cannot go inside this relation.
Okay, sir. Okay.
Okay, this will not become your identity relation. 1, 1, 2, 2. Suppose 3, 3 is there. 4, 4 is there. And suppose someone is saying 4, 4, 3 is there. Okay, so this will not become your identity because 4, 3 is not the form of this.
Okay, sir.
Here, only A kind of elements are allowed.
Sir, what is the difference between reflexive and identity relation?
Sir,
Sorry,
suppose
I am
the
come to the.
4 term
Let
is
me come
not
to
injected.
reflexive first.
So
Sorry.
is it
Sorry.
also the identity matrix?
Sorry.
If the 4, 4
I'm
and
not
3,
getting your point.
then 4, 4 suppose is not included in the set, so it's still the identity matrix, identity subset.
No, if 4, 4 is not there, it will not become identity relation. Okay. Okay, so reflexive. So a relation R is said to be reflexive if and only if for all A belongs to R, this AA belongs to R. See, here is a basic difference between this kind of thing and this kind of thing. For the same example, A is equals to 1, 2, 3, 4. What will become your reflection relation? For all A belongs to R, A has to be inside R. It means that for 1, 1, 1 is there. 1, 1 has to be there. For 2, 2, 2 has to be there. For 3, 3, 3 has to be there. For 4, 4, 4 has to be there. Apart from that, if there is some element wants to come inside, they can. Suppose 2, 3 is there. 3, 4 is there. Okay. This relation still become an reflexive relation. Okay. This is also a reflexive relation. So why? Because what it is saying, for A belongs to R, if A is coming inside R, this pair AA kind of pair has to be inside R. A belongs to A. Sorry. For if A is inside A, this pair A has to be inside A.
So identity relation is a subset of reflexive relation. Am I right, sir?
Exactly. Good observation. Yes.
Okay.
If identity relation is a subset of any relation, this relation is known as, that relation is known as reflexive relation. Got my point?
Okay, sir.
In that reflexive relation, there will be that kind of element will be allowed.
Okay, sir. Okay.
Okay.
Okay, sir.
Okay. Then next is symmetric. Symmetric is saying a relation R is said to be symmetric if and only if AB belongs to R. It means that if A and B are related, this implies B and A has to be related. What it means? It means that if suppose in this example A is equals to 1, 2, 3, 4. If 1, 2 is inside this relation R, then if 2, 1 is inside this relation R, then we will say, yeah, this relation is symmetric. But for all AB, okay, for all AB belongs to this. It means that whatever pair is belonging to R, suppose here some kind of, suppose 3, 4 is going to inside this R. So if R is symmetric, this implies that 3, 4 automatically go inside this R. You're getting my point? What I am saying, if something is inside R, its symmetric part, it has to be inside R. Then we will say, yeah, it's a symmetric relation.
The last line, there is a confusion. It's 3, 4 belonging to R. Again, 3, 4. It should be 4, 3, right?
No, 4, 3, 4.
Yeah, thank you.
Actually, the session is already 2.5 hours. So that is why I'm...
No problem.
It's very difficult to take this kind of second, like long.
Very tiring.
And this time, this is my first session, so that is why. And
Really
tomorrow I have
excellent.
classes.
Excellent, sir.
And tomorrow I have class at 8 o'clock. 8 o'clock. So that is why I have to think about it.
A clear understanding.
Okay, symmetric is understood.
So
If AB kind of thing inside R, if something is going to inside R, its symmetric part has to be inside R. Then we will say, yes, this relation should be symmetric relation. Got it?
Yes, sir.
Okay. What is antisymmetric then?
So opposite. Symmetric. That is.
Not opposite, okay? Not opposite. We cannot say opposite. There is
Okay,
a
sir.
difference.
Yes, if there
Okay.
AB is present and then BA is present, then A should be equal to B.
Yeah, exactly. If AB is present inside R and BA is inside R, then we will say this is nothing but this both thing is equal. Okay, we cannot say it's the opposite of this. What will be the opposite of this? Opposite of this is saying if AB is inside R, BA cannot inside R. Okay, suppose A inside R. But A inside R, it means that it's according, if Abhi will say about this opposition of this kind of this symmetric relation, then this implies A cannot inside R. This will become a contradiction, right?
Yes, sir. Yes, sir.
Right?
Yes.
So we cannot say this is an opposite kind of thing. This is not opposite.
Okay.
Okay, not negation kind of thing. This is
Okay.
different.
Okay.
So it is saying AB inside R and BA inside R, this implies A and B both are equal. That's it.
Okay.
Or you can say if both are not equal, A equal to B. Or you can say if A is not equal to B and AB belongs to R for distinct A and B, then this implies AB cannot be inside. That you can say. But for equality case, this both becomes.
Yes, sir.
Okay.
In case
So
of
this is the
equality,
notation.
in case of sir, in case of equality, antisymmetric may be an identity.
Can be, we can see like that.
And the last line, A not equal to B, AB belongs to R implies BA not belonging to R.
Yes, yes, sorry.
Okay, no, it's okay, I understand.
Okay, please let me correct. Okay. It's very late actually. Actually, in the last term, the session was starting from 8. Okay. So it was very helpful for me because 8 to 11, it may be doable. Right.
Okay.
But 8:30 to 11:30, it's like very difficult.
No, I mean, if you're tired,
Maybe revision say
we'll finish.
Revision, I mean, most, yes.
No, we will close the class if you're too tired. Like, why should we go on?
No, it's okay. It's okay. Last topic is there only, that what transitive relation. Transitive relation. Okay. So what is transitive exactly? If AB belongs to R, nothing is there, and BC belongs to R. Just focus this first, and this is the last entry, and this first entry, both will be same. This implies AC belongs to R. Okay.
Yes. Yes, sir.
What is the basic doubt here? So someone is saying, sir, if 1,4 belongs to R, suppose, for example. Okay. And 4,1,4,3 is there, but it is not inside R. Okay, just think about. So, sir, if can there will be possibility that 1,4 belongs to R? There will be possibility, but it is not necessary. 4,3. Okay. No, sorry. 1,3. There is no such thing is there. Like there is no constraint. For any constraint in this 1,3 case, we will apply only whenever the first two thing is happen. If first two thing is not happen, we are not going to see anything. Okay. If this kind of thing is happen, suppose 1,4 is coming inside R, 4,3 is not coming inside R. We will not talk about 1,3. We will ignore them.
Understood.
Okay. We will ignore them. We will discuss only when this kind of thing happen. Suppose if 4,3 is inside R, 1,4 is also inside R, then only we will discuss about 1,3, whether it is inside or not. Okay.
So
if it is not happening, we will not going to discuss.
So can we call it transitive relation if it is not there?
Sorry?
No. So if 1,4 is there, 4,3 is not there. In that case, can we still call it transitive?
Yes.
Exactly. Suppose you have relation like this. 1,4. Only one element is there. This is also a transitive relation because you don't have anything to check the second thing. Anything you don't have.
Sure. Thank you.
So there is no such issue.
Got it.
Right. But this is not a transitive relation. Suppose you have like this. 1,4, 4,3. Okay. And then 1,2.
Okay.
This is not a transitive relation because this both thing is there, but 1,3 is not there.
Got it. Clear. Thank you, sir.
Right? If something is there, for that this thing has to be there. If something is not there, we cannot do anything.
Sir, instead of
That's
AC, if CA is present, then
sorry. If C is present. Suppose you are saying, suppose, sir, here 1, 3 is also there.
no, sir, if 3, 1 is there.
3, 1 is there. Just you are saying, sir, if 3, 1 is also there. Okay, then we cannot say anything now. 1, 4 is there.
The
4,
4
3
1
is
should be
there.
there.
For that, 1, 3 is there. 3, 1 is a different thing.
No,
You
here
have to
4
see
1 should
this
be there.
last one
Sir,
and this
but
first one. That's it.
4
Yeah.
1 should be there.
4, 3. For 4, 3, 3, 1 is there. So for that, we have to see about 4, 1. Okay. Whether it will be there or not. Because here 3 is there, 3 is there. Now we will see these two pairs.
Okay, sir.
Getting my point? So basic thing is there. If AB is there, AB is a different number in R, BC is there, different number is R, then only we will say, yeah, if it is transitive, then AC has to be there. If one of the condition is not satisfying into the one in those two, we will not going to see about this AC. Okay, then sir, we require 3, 2 for R to be transitive. Why 3, 2? Okay, 1, 3 is there, 3, 1 is there. Then 1, 1 has to be there also.
sir,
Yes.
sir, if 3 1 is there, then it will not be transitive, right?
If 3, 1 is there, it will not be transitive. Yes, because for that 4, 1 has to be there.
Yes, sir.
Okay. It depends.
Yes, sir.
Just go through the definition only. Okay. So one suggestion from my side, please try to do practice assignment from yourself only. Okay. You just ask only when you are not getting anything from that. Then only you can master the thing. Otherwise, what happens? It's just like in every exam, that kind of thing happens. We will learn like teacher will teach you like a river. Syllabus is like ocean. Teacher will teach you like river. You will get like a cup of water and you are writing just drop of water. That kind of thing happens in every exam.
Sir,
No, it's not a daily class. Maybe it's on basically on Sunday. Yes. Yes, someone was saying. A close session was
sir,
closer. You
sir,
can go.
asymmetric relation भी बता दीजिए.
Asymmetric relation. Okay. Asymmetric relation is part of your course?
I don't think so.
Yes, sir.
Asymmetric relation. Okay. Excellent. Thank you. Oh, thank you very much. Okay, so basically asymmetry. Let me think. What is it? Let me check. Okay, I am confused because the both things are same actually. Antisymmetric, asymmetric. Sometimes they are confusing words. Let me see the definition.
Sir, asymmetric is not in our course.
Yeah, that is why I did not mention. Let me, but I will tell you what is asymmetric as well.
For equivalence,
Yeah, equivalence relation is easy, right? Just a minute. Both are looking like same antisymmetry. Huh?
So asymmetry relation is somewhere opposite of symmetry relation.
Hmm. Just a minute, okay. Let me see. Okay. Okay, so yeah, you can say like that. Why? Let me. Asymmetric relation is saying even if A is equal to B, if AB belongs to R, this implies that BA cannot be belongs to. Even if this is equal, means that A cannot be part of this R.
Effectively, identity should not be there.
Exactly. Right? Any element from the identity relation should not be there. Okay, not identity.
Okay.
Okay, sir.
Okay.
Sir, in the relation
In the
for 1,
antisymmetric
4
relation,
and
we are
4,
allowing this kind of relation. Your voice is breaking. Your voice is breaking. Your voice was
hello,
breaking.
sir, am I audible?
Yes, Kiran, right?
Is it clear now?
No, your voice is breaking. That's what I'm saying.
Hello.
Equivalence relation is
Hello.
nothing but just a minute. Equivalence relation, if a relation is reflexive, symmetric, and transitive, or if a relation is reflexive, symmetric, and transitive, then we will say that relation is equivalence relation. Okay, nothing is there. Yes, someone was asking something.
Sir, am I audible?
Yeah.
So in the
Others can leave the
last
session.
relation for 1, comma 4 and
Antisymmetric.
4, comma 1, 1, comma 1 is not there, so it is not a relation. We have to check
It's
each
not
and
a
every
symmetric
pair.
relation. It is
I'm
not a
saying it's not
transitive.
transitive.
It's not transitive. Yeah,
Transitive.
it's not transitive. Yes. You have to
So
check the
in the
pairs.
symmetric relation also we have to check every pair, right? For every
Yes.
pair.
You
Then
have to
if
check
any
symmetric.
extra pair is there, even one pair is there, it is not a symmetric relation.
Exactly.
Okay.
Exactly. You are right. Okay. Thank you so much.
Sir, what about
Thank you.
binary relation?
Binary relation, I have already told you now. If
Yeah,
your relation is defined from a same set, like
is it
binary relation
symmetric?
is like no.
No.
I have already told you now. It's not symmetric always. Any relation. Okay, thank you. If B is equal to your A and your relation R is subset of A cross A, then we will say this R is a binary relation. But there are 4-5 types of this binary relation. One of the part is symmetric relation. We cannot say all symmetric relation is a binary relation. No, sorry, all binary relations are symmetric relation. We cannot say like that. Symmetric relation is just part of binary relation. It's not exactly like all the binary relation are not symmetric relation in general. Okay,
Can
there may
we
be
say
some
about
binary.
how symmetric relation can be binary?
Always, because that is the part of it's just like all squares are rectangle. Okay, this is a square, all squares are rectangle, but does all rectangles are square? No, na. Similarly, suppose this is your symmetric, this is your binary. So all symmetric relation are binary, but all the binary relation cannot be symmetric.
Okay.
Subset you can say. Types.
Binary is like a superset.
Okay, thank you. Yeah, you can say.
Thank you so much.
Classification. It's just a classification of binary sets. That's it. Binary relation.
So you
Okay.
letter.
Okay. Good night,
We
guys.
enjoyed your class, sir. That's very
Sir,
good.
sir, last time, sir. Hello.
Thanks,
Hello.
sir.
Sir, can you please check this with team who deal with the uploading the course content? The maths we
Yeah, I will
we
let
have.
them know. I will let them know. I will
Okay.
let them know about your that particular thing, like some of the person is not getting their graded assignment in the test scores. Some of
Yes,
them
sir.
not.
Also the supplementary contents where we get the books and
Yeah.
PPT
And
lectures.
sir, week 2 content also maths.
Week 2 content, there will be some separate dates which are already decided. On that dates only they will release the content. That's the thing. I
Sir,
don't know date exactly,
sir,
but
all subject
there is some
released, but
specific.
except for maths.
Okay, I will let them know. Okay.
So
Okay,
CT2
what are the
graded
doubts exactly?
so CT2 graded assignment also not there.
Okay, let me write the whatever the issues you are facing, guys. Please let me know. First is
So practice
the
assignment
grade
solutions are not available for maths and CT.
practice assignment solution. Maybe TA session will be there. Okay, so don't worry about it.
Sir, week 2
Graded
maths content
assignment.
not
What
there.
is the problem on gauge? Just a minute. What is the problem on graded assignment?
Sir, in CT2 the graded assignment not there. Only course was there.
Okay, so for computational thinking, you just tell to who is the instructor of computational thinking. I don't know anyone's from computational thinking. As I earlier told you, I am just a newly joined faculty. I am just a newly joined instructor. I don't know who is CT instructor. I don't even go to the that building as well. So that's the thing. I don't know them. I don't have contacts them. So you just ask with CTTAs or maybe some CT instructor. There will be some live session, right? You just told them. Is there any issue with Math 1 or Math 2? You can tell me.
Yes, sir, week 2 content is not released.
Week 2 content. Not release. Anything else?
And also, sir, supplementary contents.
Supplementary content. Okay. Anything else?
So some of the students get practice assignment 1.1, 1.2, 1.3 like that, but I didn't get that anything.
Some of the student did not get practice assignment, right?
Yes, sir. Practice assignment 1 is there, but 1.1, 1.2, 1.3 is not there.
Yes, sir, only one practice assignment is there.
Is practice assignment available for the CT and other courses as well?
No idea because I am not in that course. No.
Yes, it is
You
available.
just ask to your
Available.
you can ask to your classmate.
Sir, I have that doubt in definition of set.
What is the doubt?
So suppose if we
What
collect
is
some person name and things together, then can we call it a set because they are not well defined?
it you have to see whether it is well defined or not. What is the well defined mean? That means that it has to be same for each and every person. If it is the same for each and every person, you can collect that kind of. Okay, suppose for example you are saying like that, right? If a collection A contain two people, say Ram and Shyam, and another set B is there, suppose it is containing 1 and 2, and another box is there which is containing this kind of thing is there all together, Ram, Shyam, 1 and 2. This is also an set, okay, known as A union B. Got it? This
Yes,
thing
sir.
you have already done, I guess. I hope you have already done. Okay.
Yes,
Okay. So
sir.
good night, guys.
Thank you, sir.
sir.
Okay. Good night.
Hello, sir.